All right. How's everyone doing today? Welcome to the stream. Today's gonna be fun. This is gonna stream where the content could probably do like a front end masters. I think like it's gonna be a lot of teaching. Versus, but I've never done this content before, so this is more of a gonna be a bit of a trial run comparatively. I probably should have prepared more, but I always start explaining signals and reactive rendering, and then I stop because that's when stuff gets difficult. And today I want to look at the difficult parts. It's quite hot in Cali, yeah. Yeah, nice warm January day in California. Yeah, how's it going? Hey. Yeah, but well, I had an idea. We'll see what you all think about this, but I thought it would be fun before we got even into the whole like what is fine grained rendering, how it works, is to get a perception with chat and you all of what rendering is or rendering performance in the browser even looks like. And for that reason, we're actually going to play a little game today. We're going to make a tier list. I've never made a tier list before, but we're gonna make a tier list, a JavaScript framework or library client performance tier list. So if that's something of interest to you, you should definitely check it out. Help me build this list. Obviously, these opinions ultimately will be mine from my experience of benchmarking. So obviously they are completely 100% correct. And if you disagree with me, you don't know what you're talking about. No, I obviously um, there's gonna be some disagreement, some differences. I don't think my placement will be off by more than one place. Um, but I think it would be fun to build a tier list. So I'm actually gonna pop blue sky, let people know that we're live. Um, and I think we're already streaming live from X, so that makes things a lot easier. Um, where are we going to be? I'm going to say Twitch TV. Sorry, I know I'm not sharing my screen right now. It's been a while since I've actually. Oh, okay. Yeah, so we got some people coming in. I'm glad you all could join me. Will we be looking at? I will look at some unreleased ones too, but I don't know if I can put Marco 6 on. They're still under the I don't know what you want to call it. I don't want to call it a ban, but sanction. Marco 6 is sanctioned. Just want to make sure I actually have my oh no, okay. So Ryan Solid 9 is actually my YouTube, I think. I think I actually have Ryan Solid on Twitch. I can never remember this stuff. Beautiful. Okay. And actually, we're going to include Rust frameworks too. So let's make this front end client performance tier list. I'm trying my best. Okay. All right. All right. All right. Um, let's see here. Let's get the screen going. All right. Sweet. Got the retweet on Blue Sky. But yeah, look, I've already gone through all the effort of finding the logos to basically every JavaScript library or whatever, and the reason I'm doing this is because it's going to be a very illustrative way of, I think, of showing that while different render techniques matter, different elements actually end up impacting these things a little bit. It's not like just a one for one. Certain things might overpromise, underpromise, but I'm looking here at purely client side rendering. What, so I'm not focusing on primary backend frameworks. You won't find a Next.js on here. And I'm looking at declarative libraries. jQuery just doesn't make sense because it's like vanilla JS. Like there's no, like you can write it as infinitely. If you want to know, vanilla JS is God tier. It's above S tier. It's not even on here, but I mean, yeah. So like, yeah, jQuery is God tier as well from that perspective, right? So we're just have some fun here because I actually laid them out in the order that they were released. Would you believe it that the very first declarative JavaScript framework that was released, not the most first to get popular, but released by date, was actually my buddy here, the big K, Knockout JS. At least in my knowledge of JS frameworks, I'm not aware of some. These are just all the ones that I am aware of, roughly on dates, right? Brendan made JavaScript and then jQuery made the world. Yes. Yeah, it's like the kind of here for the history lesson. Yeah, I mean, there's a bit of history lesson because this lets me tell the history a little bit too. So I was thinking I'd just go in order, right from start to beginning. But the truth of the matter is I realized as I kind of sat and looked at this list that there are definite anchor points, right? And almost this whole chart has to be anchored around the most successful, most popular, most known JavaScript frameworks. Otherwise, you guys watching won't have a state of reference to understand what we're talking about. Yeah, there's 3 views. If you see multiple logos, it's because I intend, there's 3 sveltes as well. There are some frameworks that have actually made significant differences on specific releases, enough that I'm going to call out. But like most of them kind of sit in the same zone over and over and over again, mostly. So actually, yeah, I mean, let's start with React, because React is it's the thing that everyone probably has experience with that they can put on a state of reference. Where should I put React? What do you guys think? I have an idea where I should put React, but I want chat to help me out here. Anyone guessing where I'm going to put React? All right, we got an E. Come on, chat. I need some participation. An F. We got C. Xcan, I think it says it all. C or D. C. Yeah. Okay. B. C right in the middle. C or B. Yeah. And you're correct, actually. Qwik, I'm going to be as fair to Qwik as I could possibly be. But if you go check the benchmarks, like the last couple months, Qwik has for some reason fallen off the deep end. I'm going to assume that's temporary and that they'll get themselves in order. But I'm going to try and look at frameworks in their largest historical context, but judge them as harshly by the criteria that we have today. D, C, D, yeah, B, C. Yeah, so all over the place, right? This is why we have to start with React, because without React, we don't have a frame of reference. So for me, React is a solid D tier. I think it is basically, it's not the worst we've seen. It's far from the best. It's still considered a passing grade, but barely. Yeah, we are talking purely about front-end render performance. I think that's a fair assessment. Qwik, though, if you go on the benchmarks right now, is like an F. I don't know what happened, but we'll get there. A, vanilla, B, solids. So. Okay, so you're just doing the whole chart for me right out. All right, let's keep on going. Okay, so now we have our frame of reference. All right, let's go back to the beginning. Where should we put knockout.js? If React is a D, where should we put knockout.js? The first declarative JavaScript framework. Used signals back in the day. Because I'm a stickler to performance, surprise, 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 I see some B's going in there. B's. Knockout's actually an E. I get why you guys see. When it came to updating very specific parts of the DOM, Knockout to this day still runs circles around React. The problem with Knockout, though, was you had to create the page. You had to actually render the stuff initially, and Knockout would go through your HTML templates and find all the data bind things and then reprocess it, making it actually incredibly slow to render. So even though it could update like the specific text on your page way faster than React, and still does, it generally was slow. You go one page to the next page and you're actually, it's slower than React, right? Do you guys recognize this logo? Before you can bake a Knockout app, you have to create the universe, right? Knockout was a fine-grained renderer, actually. This is actually why I'm doing this chart. Knockout, the very first framework, was a fine-grained renderer. It doesn't just have signals. It has what we're going to define as fine-grained rendering. It was the first fine-grained rendering framework. It was possibly the first declarative framework, but it actually was a fine-grained renderer, and it had signals. It just was so bad at actually rendering the HTML, like Knockout was smart. If you changed a control flow, it didn't re-execute the whole tree. It did partial, it had all the aspects of fine-grained. In fact, Solid's original control flow, I learned how to write Solid control flow by looking at Knockout's internals. Knockout had pinpoint updates and modern fine-grained control flow. So it was a fine-grained renderer. It just was bad at rendering. Yeah, so let's go. Backbone. Backbone's a tricky one. Backbone, as described, would re-render the whole, people would use Backbone and then they put almost like jQuery type enhancements. If I use pure Backbone and had it redo the templates, the thing you have to understand is this is all pre-virtual DOM. So Knockout said, hey, put a bunch of, observable signals in there and update little things. Backbone was like, we have models and then we revalidate views, which means completely recreate them from scratch. Yeah, it's hard because part of me says that Backbone should be like E. I don't know if there's actually a considerable difference between Backbone and Knockout. It's on the fence. I'd say it's below Knockout, but is it an F tier? Thinking of the benchmarks at the time, like the spinning circles and stuff, Backbone was actually fairly good on updates. I think that's going to put in the same category as Knockout. This one's controversial, but let's keep Backbone with Knockout. These are all client-side frameworks that basically all do the exact same thing. They are literally there to update, create apps and update. This is not like something you choose because of a use case. These are almost all completely equivalent. They have special defining features, but they're all almost equivalent. Right? And we are considering legacy here because we are starting historically, right? I haven't caught up to React yet. AngularJS. Angular JS, like Angular 1, is a tricky one. It 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 actually, and because of benchmark time, look at Hype.js, React 14 or whatever, it's actually, I'd say on average ahead of Knockout, but below React, which sticks it solidly in an E tier for me. It's close to D, but like for me, from performance and stuff, Angular 1 was never like it was dirty checking in a sense. You can say that Angular 1 was the first block DOM approach. We'll get to that later. But it was a dirty checking system that did a lot of unnecessary cycles and re-rendering, and those things cost more. And the last one that I'm going to talk about that came out before React is Ember. Ember was like Knockout. It had originally, Ember's over time has evolved. I probably should have more Ember on here. The only reason I won't have more Ember on here because the newer versions of Ember did not actually ever change its performance profile. Ember to this day still is in the same place, even though it's completely been rewritten in new engines and Glimmer and all this kind of stuff. Unfortunately for Ember, not everybody can be a winner. From a performance standpoint, Ember had great features. I was an Ember developer. I was a Knockout and Ember developer. Brian Florence was an Ember developer. But like it was basically just slower at everything. Like even though it used reactivity to do like some kind of fine-grained stuff, it was still even slower doing that reactivity. And then they replaced the engine with almost something like a VDOM, and it was still the slowest VDOM. And then basically every historical line of the way, Ember has always been pretty slow. Don't get me wrong, there are frameworks on this list that are slower than Ember, and we'll get to them. But this is what the first 3 to 4 years look like. There was more frameworks, but you guys wouldn't have heard of them. I tried to pick frameworks that have like over 10,000 stars today. There's a few exceptions, but they're ones that possibly you could have heard of. Yeah, bottom of the E tier. I'm going to give it an F though, because it's, yeah. This is maybe a good sign that performance doesn't matter. But what I want to show you is, look, now this is up to 2014. We're sitting at 2014 right now. React looks pretty sweet here in 2014. Right? You're reserving F for Blazor. I mean, that's fair too. But yeah, we talked a little bit about each one. React, the first virtual DOM library comes out at this point, and it is significantly better, a whole category better than every other library that came out at its time. It was not the first declarative thing. It wasn't the first, like, I'm just a view. Knockout has the exact same advertisement, but it was significantly better than everything up to this point, right? We can't do jQuery because it's not declarative. That was one of the things I said right off the bat. It's God tier. jQuery became vanilla JS. You can write the most optimal code possible with jQuery. It's basically S+. It's off the top of the screen. I almost have to put it on just so people are like, where's jQuery? And be like, up here somewhere. Because you're right. As people join on the stream, they're going to be like, where is it? Okay. This R, I just included this one because I needed something else also from that time period, 2013, 14 time period. This is Reactive. This is Rich Harris's originally reactive framework. It was used git.set and set for its like signals implementation. It's very early work in him making kind of like a Knockout-esque framework. And so it is also pretty solidly E tier. But just wanted to give a quick shout out there because Rich Harris was already there pre his Svelte days. Awesome. Great to see you. Right. Blazor deserves its own category. You guys are so mean. Yeah, React is still, like now we're getting into 2014. What else came out in 2014? Marco. Marco actually, and I don't know the 2014 counts. They're primarily a server-based framework, right? They invented islands, out-of-order streaming, basically suspense. By 2015, they had all the features that we talk about these days. But we're talking about client-side rendering. So Marco, surprisingly, I don't know if you guys know where Marco goes. Where do I see some S's and A's in there? I don't want to disappoint you all, but Marco is not for client-side rendering thing. Marco is actually, I'm going to put it D. These days, I think it's kind of slid to an E, but it's always been very close to where React is. Yeah. 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 So we're after React, we're starting to see other frameworks kind of come in and go, oh, I can do what React does. Marco in version 3, I think I want to say around 2016, introduced its own virtual DOM and, pushed it a little bit more, but we're not there yet. I'm basically going to put Marco around here. All right. Now we got Vue, and I'm going to count this category as Vue 1 and Vue 2. I know there was improvements over it, but yeah, we're now getting into 2015 now, right? Okay. Yeah, so Vue 1, Vue 2 is actually an interesting one. You guessing B tier? That's not a bad guess. Not a bad guess. C, I think. D tier, maybe C. Yeah. Yeah, Vue, I'm gonna give it our first C tier. I don't know what about it. I think it was a slightly faster virtual DOM. They had signals under the hood to kind of make its re-rendering process a little bit better. But generally, if I go back as far as I can, Vue has been basically just a category above React. Vue always underrated. Yes, I did say talk about Vue being underrated, being a topic of the stream. This is also the last time that Vue is ever going to be ahead of anything for the rest of this. But Vue initially was very, did make a big impact. Yeah, getters and setters for data. You're getting ahead, but we'll see. Right, so Vue is pretty good. But Vue was not the only one. Around that time, single file components started showing up. We had things like Riot. I don't know if anyone's familiar with Riot. I imagine not, but I'll help you out. Riot is also a C. Like Vue, these are new VDOM libraries that use signals essentially, or under the hood, some reactivity to trigger their VDOM. And what else? We're still in this like 2015 heading into 16 period. You guys might not know this one, Mithril. This one was like a faster, pure functional approach to the VDOM. I'm also going to put that as a C. Basically, people saw React and they're like, we can do better. Right? And they did, honestly. As time kind of went on, we start seeing things fill in. I'm not actually sure. I guess it's still going. I haven't heard people talk about it as much, but there's definitely a contingent of people who tried to come over to Solid because of the optional, and they're trying to use like the JSX without the compiler from the Mithril community. A Mithril community is a special one because they cared a lot about performance and functional purity. So at this time, the React core devs had this like real functional push kind of core like, but like, yeah, I don't know. Where's Aurelia? Yeah, I don't have Aurelia. To be fair, I just realized I don't have Elm either. I Aurelia showed up around this time period too. The tricky part is it didn't. I guess it has gotten over the 11K stars, so to speak. Yeah, I don't know as much about it. Let's see. Elm logo. I feel like we should get Elm in here. Because we because this is kind of like one of the first what should I call it? Like yeah, this is one of the first like compile to JavaScript framework pieces. So let's get Elm in here. Because Elm, yeah, okay, I got to think about Elm for a second because I haven't really thought about Elm very much for a while. It's tricky because Elm is might be it's hard. It's either C or it's yeah. I'm trying to think of because like I know offhand where Elm sits these days, right? It's kind of a C, maybe. But I feel like historically it might have been more of a B. So it's like, oh, it's tricky. I'm actually gonna pull up an old JS framework benchmark with Elm back in the day, just to kind of get my bearings here. Yeah, let's look at this. Elm. Cause like, okay, Mithril 122, Vue 2, 115. Uh yeah. Elm is 1.34. Ember is 2.14, just to give you say I don't know why Mithril's slow on this one. This is pre-release. Yeah. Mithril's like 1.22 there. Okay. Yeah, okay, that's good enough for me. I'm gonna put Elm as a solid C. Okay, so there we go. We got Elm in here. You're starting to see a trend, right? Yeah, I'm not sure if Leo is. Leo is great, by the way. I just, especially early on, there's sometimes different framework authors help other framework authors when they get started, and other ones, are just busy doing their own thing, which is perfectly fine. Uh, Leo was always very supportive of my work in Solid, and I sometimes think part of that, might have inspired me to, help others. Okay, so let's keep on going. It was a VDOM like React. But again, what we're seeing here is a bunch of VDOM libraries that are slightly improved over React. So the next one on here is important. This one, honestly, I think is going to be the most controversial placement for me. Where does Inferno go? Because there's clearly a trend. You're seeing how we're kind of building up. We started in E. React showed us that D was possible. And then, Marco came in and then a bunch of these guys improved. But then out of left field, we get Inferno. And Inferno, if you go look at tests and stuff today, it's probably verging S tier. But the thing is, the funniest thing about Inferno is about 2 years ago, something changed in the browsers and Inferno suddenly got faster without the code changing. So like, it's like, should have it always been faster? Most of Inferno's life, it's been a solid A tier. Oh, why can't I drag anymore? So I'm gonna put it here for now. It's questionable, but it's it's it was the first framework that was like it just skipped the category. There was no B frameworks. Things that people are just kind of creeping past React to C, and Inferno's like, yeah, you guys, this space is a lot bigger than you thought. Like when React came out, people were like, oh, we've probably hit web rendering performance pinnacle, and Inferno was like, you guys aren't even halfway there. What's questionable is whether Inferno should be S tier. Yeah, power static analysis in JSX. Dominic Ganaway, way ahead of time in its approaches in terms of optimizing. He took something that looked like React and made it way faster by clever engine level optimizations and using static analysis on JSX, which would later lead him to get hired at Facebook to work on Preact for the React core team. And his compiler skills will come up again because he was also the lead on Svelte 5. So this is I already mentioned where Rich Harris kind of jumped in the game back with Reactive, but Dominic made quite the debut. One of my favorite people. We did a stream with him about a year and a half ago. You should check it out, Dominic. I'm actually going to pull this off YouTube so that I can share it with you. Dominic is a wizard. Which is coincidentally the stream cover here. Let me see if I can share it. Yeah, got it. And actually, I think I'm going to keep part of that stream around because he has the best quote that's going to be relevant for the stream. Yeah, he worked on Lexical at Facebook as well. Kind of the React core team. The tricky part with compiler analysis is you need to set some certain boundaries or rules or constraints around it. And the React core team with the concurrent model wanted to go a different way. So basically, they weren't able to apply his optimizations, and he found himself kind of sitting on the React team and being like, how do I fit in? The projects are the interest stuff that they hired him for, because like he basically blew everyone away with Inferno. He found himself like not being able to actually work on React moving forward. So he picked another incredibly difficult problem, which is getting high performance in text editors, along with accessibility. So there we go. We got Inferno. All right, next is Preact. Where do we think Preact come up? Those two came out almost, I think, a month or two apart from each other. We're right at the end of 2015 right now. No, I will not be placing Vanilla.js or jQuery. They're god tier. They're above the whole list. Yeah, no. Preact, I follow benchmarks. Preact actually, from a performance standpoint, has always basically been another one of these Cs. It's a good C, but it actually, most of its life has lived very, very close to Vue, maybe even slightly behind Vue. So Preact's going to be a C. All right. We'll talk about Preact with signals, I think, but we'll get there. Next one. I'm using the modern logo, but I'm only going to give Angular a second thing. It's arguable that Angular 19 forward, or the next version of Angular, like there should be another Angular at the end of the list and it should use this new logo, but I'm now doing Angular instead of AngularJS. A is Inferno, created by the author of, I shouldn't say the author. Inferno was put him on the map. Created by Dominic Ganaway, who's also took lead on Svelte 5 and also author of Lexical and former React core team member. Order doesn't matter. I'm just putting them in the order that they were released at the specific tier. So Angular 2, 3, 4, 5, whatever. D, maybe even E. Anyone else got any guesses where I should put this? I'm waiting on you. What do you got? E, D, C, S, D, C. Yeah. Angular. Angular has always, this is the weirdest thing. I don't know how they do it. Angular and React have been lockstep for basically forever. I like only recently. That's why I mentioned it. In the last year or so, I've been seeing stuff, maybe different types of control flows and stuff, like things starting to where Angular is separating itself. But no matter the release, no matter what came out, React got a little bit faster, Angular got a little faster. They basically have been lockstep for all of time. Right? Is the same at the well, the funniest thing is most frameworks actually move up at the same time. So generally actually yes. There's not enough, it's very rare that frameworks actually move more than maybe half a tier away from where they were sitting comparative to their competitors. No, this is not Angular powered by Signals. This is Angular like for the last like this is Angular 2 through I don't know 17 or whatever. Yeah, I mean it would be, but I'm gonna make you work. People who know will know the logos. It's a lot of libraries here. Um, yeah, Angular with Signals is probably a C, maybe even a B. The funny thing is, Angular tends to actually always be just a tiny bit ahead of a React. It's funny because when you talk to the Angular folks, they like React. I don't pay attention to React. I don't look outside of Google. Like historically, but they've always somehow managed just to be like right there or like right in front of. All right. Now we get Svelte 1 and 2. So we get Svelte 1 and 2. I'm not that familiar with Svelte 1, but so this is basically Svelte 2. Svelte 1 and 2 is any guesses? I know because I'm the one who did the upgrade from Svelte 2 to Svelte 3 in the JS framework benchmark. But this is Svelte 2. This is before it got the updated syntax and the new compiler and all that kind of stuff. Got some C's, some B's, some D's, B or C, yeah. I'm going to say that Svelte 2, oh man, was a significant improvement over, or Svelte itself was a significant improvement over Reactive, but it is also C tier. Yeah. All right. It uses signals and it uses like a form of dirty checking under the hood. It's funny. Dominic Ganaway, yeah, we'll get to his quote in a little bit. The disappearing framework thing really caught on with Svelte 3. If you've never seen old Svelte 2, it looks more like Reactive. It had like single file components, but it had like .get and .set for state. There's no like let variables. Svelte 3 is a Svelte that everyone knows. This is the Svelte that only people who were doing benchmarks knew. It was not very popular. Right. So as you could tell, now that was 2016. That was actually the end of 2000s, towards the end of 2016. This framework might have actually come out before Svelte, and I might have put it in the wrong order. But we have Inferno at A, and everyone else is kind of below it. This one here's a small framework. Blazor has a client rendering framework, to my knowledge. HTMX does not. Blazor actually has like a JavaScript framework that does rendering. This one here is a small one. This one's called Imba. It was made by like the Scrimba people. It was a compiled language, kind of like Elm concept, and they kind of called it out as like the fastest framework. They made this stupid benchmark that Rich ended up using in the Svelte 3 release, where they showed it was like 20 times faster than React. The reality is it wasn't. But if you're looking at the time and the type of frameworks that were popular and available, there were other faster frameworks. I don't have like the fastest VDOM things. They weren't that popular. Like other than like you can imagine when Inferno came out, that there's like half a dozen other smaller frameworks that work like Inferno, but nothing that kind of caught on. Imba solidly is going. Many of you probably don't know it, but it's going to be our first B. Can't drag on this computer at all because it's stupid. It's going to be our first B tier framework. It actually did have significant performance improvements over what had come before, but it wasn't quite the same. Again, it was a virtual DOM approach. It was leveraging a compiler, just not as efficiently as Inferno. Its big point of sale though was like the DX. If you ever seen it, it's like CoffeeScript almost, and they're templating like CoffeeScript. It's like this. It's completely its own language. Yeah, yeah. The marketing on Imbo was really good. I remember that. All right. So we're basically at 2016 right now, and between 2010 and 2016, we went through half the list. It was a very fast period. We went from 2013, 14 with React to filling in the rest of this chart in almost no time, right? Next one I got here is HyperApp. It's got like almost 20,000 stars on GitHub. You probably don't remember. This is when library started, like Preact kind of started this small library thing because Preact was only 3 kilobytes. HyperAct was like, can we do it in like 1.2 kilobytes? HyperApp is performance-wise was a VDOM or whatnot. So it was small, so it loaded faster, but it is still going to be this dictionary popping up is so much fun. It's still going to be in this category, I think. That's why I feel like I don't know if anyone knew it. Why was Preact faster than React even before Signals? Preact always went with a slightly lighter, more optimized version of it as VDOM. Preact and React historically have been closer in performance than people give them credit for, but they've generally always just been a bit ahead. A lot of people, when Inferno came out, they assumed that Preact was like up with Inferno. Those are the two leading things, but Preact and React were a lot closer than Preact was to Inferno. Second from the left in E, that's Backbone, yeah. Okay. Preact was created probably for size, I think. I don't know. We'd have to ask Jason Miller, but Preact was considerably smaller. React even back then was still like 30 some odd kilobytes. Preact was 3 kilobytes. Inferno split the difference around 8 or 9 kilobytes, or maybe 10 kilobytes, but Inferno was about speed. No, Preact is still a VDOM until this very day. Preact is, yeah. This is why there's a lot of misconceptions out here. I really want to clarify on some of these parts. If there was a major change like Preact stopped being a VDOM, we will get to it, and we'll have a separate category. But Preact is still here. Okay, I got one for you all. Lit. It's funny because I didn't put this out here because people start saying like their favorite web component frameworks like Shoelace or whatever. Generally speaking, web components will add a tier to your performance. So like if you're an A framework and you made the web components, actually that's not true. If you're towards the top end, like an S or an A, it'll take 2 tiers off. And then if you're like maybe like D, it'll take 1 tier off. So if you had React and put in a web component, now you have E. If you had an S tier and you put it in a web component, now you'd have a B tier thing. So lit itself, I'm talking about the renderer. I'm not talking about the web components. Lit itself might be middling, but the actual renderer, lit HTML, is the one I'm talking about. You keep on saying D until I know what it is. Yeah, lit is A thin VDOM layer. Yeah. Thin VDOM for Preact. Yeah, no. Lit has no VDOM. It's a dirty checking system, but it and another lighter HTML, I think, or what was the original one? Hyper HTML by which actually came out before Lit and did exactly the same thing. Just as I said, not as popular. And he made like 4 different frameworks. Every time he came up with a new version, Andrea Giamacci ended up like making it different and then getting different GitHub stars, unfortunately. So like it never got popular, but Hyper HTML in the spring of 2017 pioneered a completely new type of rendering, bringing back dirty checking, but leveraging the fact of cloning templates. And more specifically template literals, because template literals have this weird property. I don't know if you guys know with tag template literals, it remembers the static array, like the static strings that you pass to it. So if you have I can just put something in here so you can see what I'm talking about. But if you have a tag template literal like HTML and you have a function like, let's say function my component, right? And then in here you have this, right? So you return HTML and then you put like, I don't know, div, really care, whatever. And then you have some interpolation in here where you have like some value 5, whatever. What this gets converted into essentially like HTML function, and then it's like an array of static and then like a list of the holes, right? And this static array is static forever. If you call this function 10 times, they don't recreate this array. They just know this array exists, which means that you can use this array as a stable reference, even if you re-render or recall this component over and over and over again. In a sense, it works like a VDOM, but it only fills in the holes by dirty checking the values in the holes. And the static array serves as a stable reference, kind of the same way that React hooks would keep references or whatever. Like, and this is an interesting property built into the base of tag template literals, but it basically invented a whole new type of rendering back in 2017. It works like an Inferno VDOM, kind of, yeah. And so lit HTML is small, fairly small, maybe about 12 or 16 kilobytes. And it's our second A tier. Something finally joined Inferno at the top. So credit goes where credit's due, so to speak. Even if lit, with the web components and everything, ends up maybe a B to C tier, lit HTML is a brilliantly fast renderer. All flames is a pattern, right? Well, I mean, blazingly fast. This is the original blazingly fast Inferno, right? So these flame logos were a good way of showing people that you're blazingly fast. Okay. Right. All right. Yeah, I don't know. Did Cycle.js do anything for performance? The biggest thing is popularity in benchmarks. It's hard without having it. Yeah, I'm talking about Vue 2. Yeah. Blazor needs a flame logo. Yes, this was thought for a while that if your logo will fire you even faster. Okay. Okay, now we're getting into 2018. This one you guys might have heard of. It's called Alpine. Let's see if you can guess where it goes. It's a fine-grained rendering system, like some of the earlier ones we saw, like Knockout. It uses signals. It does not use a VDOM. And it uses template data binding, kind of like Knockout did. So when it renders the template, it has to parse through the HTML to get its bindings. It is based on Vue's reactivity package, but as people should know, reactivity performance actually doesn't impact render performance very much. Like if your reactivity package is very slow, it will. But if you take almost any modern one and swap it, your framework won't be faster. That's not true of like 5 years ago, but these days, like the optimal change between reactivity doesn't make a difference. Alpine is going to be our second one to go in the F category, actually. Alpine has fast reactivity, but its templating is slow, even slower than knockouts. They didn't optimize things like control flows, even though it was fine-grained. It's interestingly enough, not even because of the Vue, because they got the Vue reactivity in their own stuff. It's not even particularly small. If you remember, there was a petite Vue thing Evan made over a weekend, because someone made some comment about Alpine being like a better Vue, even though they was using Vue's JS reactivity, and I think that you don't piss off Evan you. Especially when it's something that like literally he could spend a couple hours, because Vue 1 was kind of like Alpine or closer to Knockout. And so essentially it's basically Knockout, but maybe slightly smaller than Knockout, but generally just a similar approach to Knockout JS, just kind of worse. Yeah, I don't know. It's an interesting one because in some ways it's really easy to adopt Alpine for backends, the same way it was easy to adopt Knockout or Backbone or some of these original tier ones for backends, which has made it popular. It's like a retro version, but in some ways it hasn't actually improved, and maybe even slightly worse than the original. Like in some ways Alpine is better. They're better at handling what I call like hydration type scenarios where you're like trying to wake it up in the client than Knockout. Knockout never really considered those kind of scenarios. But on a raw performance level in the client, Alpine is none. Yeah, see, everyone says it'd be biased, but the benchmarks don't lie. Solid, I'm going to obviously, where am I going to put Solid? A tier? No. Solid was the first S tier according to the modern Wiz doesn't do client-side rendering, or if it does, it's like jQuery style. Shocked. Yeah, no shocked. I mean, we're only at 2018 now, so we still got a lot of time to go. Did modern? The funniest thing is it kind of did, but it didn't do anything. The browsers changed. So this is why I said Inferno was the most controversial thing here, because the browser changed and now Inferno and Solid are almost next to each other. Inferno might be like slightly behind, but it was from no change on Inferno's part. The browser changed. So we've seen some compiled JS libraries. Yeah, Blazor was also came out in 2018, and we're getting into compiled languages that aren't JavaScript. Blazor, some people made a joke that Blazor could have its own category, and they're not wrong. Blazor is basically this. It's like almost feels bad putting Blazor next to Alpine and Ember, because Alpine and Ember are at least a tier's worth better than Blazor. Blazor is essentially like it's hard to like if you went out and just took some JavaScript and then like JSON stringified it and then inner HTML'd it everywhere and like didn't like didn't do anything you could think of optimally, it would probably be faster than Blazor. It's not Blazor's primary purpose, but it's like, yeah, I don't know. HTML is fine. It's just that. Okay, next one. First of the Rust libraries. This one was based on React. It's called U. It's a Rust framework that renders a VDOM, just like React. See, what I'm hoping you get at here, for the most part, is from this point on, we can start getting more accurate at guessing where these things go. Yeah, U spelled Y-E-W, like the tree. Any guesses for you? Did anyone even know you? Probably faster than React, but slower than. There is an overhead of doing WASM in the browser that people had to get over, and U was not the one who figured out how to do it. That being said, U was impressive because as the first Rust compiled framework, it actually did a decent job of matching its influence. So U here is, I can spread these out a little bit. U here is actually a D tier. Yeah, WASM has overhead because of the communication and the serialization boundary. So pretty cool to see Rust on it. We've got Blazor, some C#. We got Elm. We got Imba. Where's Imba here? Some different, compiled languages. But I mean, U has almost 30,000 stars on GitHub. Okay, now we're in for a big one. One that really revolutionized the way people think. This is Svelte 3. Svelte 3 was a pretty significant jump up from Svelte 2. Not the biggest, to be fair. But Svelte 3 definitely was an improvement here. So technically, everything had been revised with the new compilation, but mechanically it was the same general idea where it was doing dirty checking that was compiler optimized. But I think Rich had moved away from, I don't know if he compiled the signals in 1 or 2, but he'd moved away from the like old reactivity and almost went straight to like, let's get rid of it all. Let's just use the compiler on the language. So yeah, Svelte, we got some guesses. We got B plus, B, A. Yeah, B plus is actually probably the where this Svelte 3 goes. I think it is a good B framework. It is, I'd say, slightly better than Imba for performance. We're gonna copy one of these. No, not that. Yeah, let's put the 3 on it so we can see that this is a 3. Svelte 3. I don't know if that shows up any good. Maybe it needs to be a Svelte red. No, that's not it. White. It's like trying to pick a color that would actually show up against the background. Maybe I just need to keep it green and then just like not overlap it as much. Keep it the neon green. Yeah, there we go. Yeah, Svelte 3. Yeah, there we go. So we have seen over time libraries kind of start getting up there, but like in terms of a timeline, this group has been taking a little bit more to move up, right? This is 2019, right? So by the time Svelte 3 comes out, we already have Inferno, we have Lit, we have Solid. It is a sizable improvement to Svelte though. Right, and then the next one I have on my list, I guess I'm jumping right to 2020. I guess the rest of 2019 was a quiet year. which is Vue 3. Was that 2020 or 2021? It doesn't really matter. They were working on it long enough. So we're gonna put Vue 3 in. And can you guys guess where Vue 3 is? Yep. Slightly behind Svelte. A little bit slower than Svelte, but solid B tier. The interesting thing about these is going from 2 to 3, they updated their change management systems, both of these frameworks, but they didn't actually change their mechanics for rendering. This is still dirty checking. This is still a VDOM, just like this is a VDOM. Yeah, September 2020. Yeah, so I'm pretty accurate here. The F tier stands for Flutter. Flutter and Blazor can battle it out. Well, Flutter Web. I don't know if Flutter Mobile is any good, but Flutter Web is not particularly impressive. Preact equals Vue, but React at this time? No, Preact is still in the same place. Preact has not moved at this time. Preact is still solid C. 2019, 2020, Preact is in the same place. Okay. Now we're getting to 2021. And the next framework I have on the list is Qwik. Incredible non-hydrating framework, has signals, right? Of the frameworks that we have listed today at this point, the only one that has signals that was created after, I mean, it's hard to say. Vue had signals under the hood, so then Vue 3 actually still has signals plus a VDOM. Svelte has an optimized compiler. Qwik is, let's see if you can guess. Qwik has signals plus a VDOM. Where do all the signals plus VDOM libraries go? The difference between Vue is a weird exception because they did incredible compiler analysis, but all these signals plus VDOM libraries are actually right here. So Qwik comes in as a C tier. Yeah, in terms of performance in the client, Qwik was great, but not in terms of performance client, it's not outstanding. It's actually it in Preact. I think they might even have the same base on their VDOM implementation, like the same inspiration. There's a couple like, oh God, what is it called? There's a few different VDOM implementations that were created back in the 2014-15 period. Yeah. So VDOM plus signals they generally highlight really well for the single pinpoint update case, but then you're paying more on the re-render because the signals are heavier than the VDOM. So if you're re-rendering stuff, signals work against you. If you're doing pinpoint updates, signals work for you. They're kind of at odds with each other. Vue, through careful compiler analysis with Vue 3, managed to just break out of that, but they are the only one that, and I think it might be true to this day, that does signals plus VDOM above a C tier. That again makes Vue 3 Vue impressive. Frameworks in A are Inferno and Lit HTML. Yeah, this isn't about benchmark. This is about client-side render performance across multiple benchmarks. Mostly JS framework benchmark, but there's several ones. This is my that I look at. This is kind of my perspective. Okay. You guys see the line face? I got one for you. Million JS. It uses a mechanism of using a compiler to basically flatten out all the VDOM nodes into cloning, similar to the way Solid and Lit does cloning, but keeps the holes kind of like VDOM-ish. Yeah. From its description, it should be an A tier list. But from its actual score and performances in benchmarks, we've got our second S tier. Million is fast. Million is very fast. Aiden came out and did this whole video where he's like showing 70% fast in React. That was not accurate. Right? But Million is definitely faster than other solutions. Block DOM in general is fast because it's basically an optimal mentality of the VDOM. It's essentially a place where you've erased everything but the holes. The way that Dominic Ganaway always described to me what a VDOM was. Right? It's funny because you see Svelte 3 and Vue 3 here, but a lot of people at this time period thought Svelte 3 and Vue 3 and Solid were all the same. This is not the case. Actually, I wonder if I'm going to try and share a clip from one of my previous streams. Give me a second. I'm actually going to change how I'm sharing my screen to share this clip. Present. Because this way we'll get audio through here. Let's do a Chrome window. I want to do, what's this one? Reactivity, ruins, and I'm gonna put Dominic on here for a second. We can listen to what he has to say.
Anyway, it was nowhere near as fast back then. It was actually much quicker just to create the elements individually or use inner HTML. So what back then I looked into was using bytecode. And it wasn't like it would represent would inference like this. Had to go there and check the code. So the idea was it would do that, and you'd get back your component, which would be.
I'm in the wrong spot. Never mind. I wanted to take a quote that I clipped from him. Yeah, well, let's forget this for now. I want to take a quote that I want to clip from him where he's calling Svelte 3 a VDOM, because essentially an optimized compiler that did dirty checking and an optimized VDOM, like a block DOM, is almost the same concept, so to speak. So let me go back to presenting my whole screen. All right. Okay. So, yeah, I mean, it's arguable that in practice, Million might be an A tier because it still has to deal with a re-render model. Maybe if you add Million plus signals, you could do something smart there. But from a raw rendering benchmark performance standpoint, when people are clocking it, Million is about as fast as it gets. Million is actually, in those kind of tests, faster than Solid. But it also can't hide, it doesn't solve the architectural problem. So there's cases where Million would be worse. If we remove spas, do we need reactivity? No, I guess. But if you can't remove, when you say single page apps, okay, no, it basically depends what you mean by single page apps. If you need client side interactivity, you need reactivity. So I guess I'll put it that way. Well, it's still a VDOM library that depends on re-renders. So even if you render the stuff fast, it's like the exact opposite of the knockout problem, When we talked about Knockout earlier, we're like, it's incredibly fast at updating the one thing, but then it sucks at rendering because it also does template processing, and whenever you switch page, it's slow. Million is incredibly fast at just rendering, but it's not as good at, like, theoretically, at doing the more granular work architecturally, because it can cause re-renders. We'll get to that. As I said, we're getting pretty close to the end of the time here on the tier list, so that we can actually get into the guts of fine-grained. I just wanted to get people thinking about the kind of terminology and things we talk about. How relevant is rendering speed in 80% case? Let's say average. I mean, it's a good question. If you're talking apps, rendering speed it can impact, like, the sluggishness and the feel of the apps to a certain degree, but how much hard to put into numbers when you're in a certain range here? How much of a difference is each one making? I'm not sure. I will say it makes a bigger difference than reactivity performance, but I don't know if it makes a huge difference. But again, this is mostly about talking about, I'm thinking about things architecturally and if they have the impact. You're right, none of this could matter conceptually, but this is just where the tools sit from my perspective. Well, this is a good time to kind of bring this up, because adding signals to another system has overhead. In a sense, solid signals plus Million's rendering technique is what solid is. He does the same thing, the cloning the nodes, and, like, I told you how Leo from Mithril's big helpers, experience and bounce ideas when I was starting. I spent a lot of time with Aiden when he was first developing Million, and you'll see a lot of solid type influence in Million. Although he also was looking at the other BlockDOM library, BlockDOM. It's actually called BlockDOM. So to be fair, there are other impacts on that as well. But in a sense, that the modern rendering technique is kind of that. It's just in, like, a rendering benchmark, you're not going to tell the difference. Like this, you'll see the signals overhead, but you won't see the lack of signals not overhead. Inferno still has a VDOM. It caches VDOM nodes, but it still has a VDOM. Browser changes have closed the gap, I think, of the overhead of doing that, where Million actually, like, gets rid of the static nodes, like, just turns them almost into templates. It doesn't care about them, where you're still dealing with VDOM nodes with Inferno. Yeah, this has nothing to do with server-side rendering and first contentful paint. It was funny, I was reading a benchmark or some client performance choice thing where they're comparing all the client-side frameworks, and they're literally using Lighthouse. That makes no sense. Like, it makes sense from the perspective of, like, I want to compare back-end technology or whatever, but if you take this list of frameworks and then only compare on Lighthouse, like, it's SSR you're testing. You're not testing the framework's render speed. Okay. Next one. Leptos. Leptos is a signals-based reactive library written in Rust. It's basically Solid.js if it was ported to Rust. The only Rust I've ever looked at was when I had Greg from Leptos on stream. It sounded really novel, but I don't know. Yeah, every framework in this list will get 100 in a hello world. Pretty much. I don't think Blazor will. It is arguable that these F tiers can't make that 100 in a hello world. Maybe that's the yeah. Yeah. Leptos, I think you guys know, there's a slight overhead. Getting pretty good at guessing. Leptos is an A. Yeah. This next one's Dioxys. It's a block DOM built in it. Yeah, Leptos is in Rust and Wasm, right? We have a few of them. We have Blazor, we have U. Leptos was huge because it actually showed that you could be fast and use Wasm. Like these ones are all in like React range, and people are like, oh, blah, blah. This is like look, if you want to write a highly interactive app where you don't care that much about maybe page load times, you can use Leptos and it will probably be smoother and outperform a React app. That's what this is basically suggesting. Dioxys is also an A, says Greg. It's weird though, because if I wasn't going to give it an A, but that's only based on the JS framework benchmark performance. Can you explain maybe, Greg, why Dioxys is like a B these days? It should be an A by all accounts, but I was like just looking the other day and I was like, what's going on? You know, it was actually, when I say the other day, I meant in preparation for the stream, because I was like, I'm expecting Leptos to be an A, because we're basically seeing like the modern takes of JS frameworks. And okay, let's just like look at this, and we're like, okay, we've got block DOM type stuff up here, solid is here, Svelte 5 is here, right? They're right next to each other, which means I'm giving away something that's about to happen. Inferno's down here in our getting into our A tier, right? We've got like this is arguably S tier still, but then we got lit. But if I look up for Leptos, which is here, it's Leptos has dropped significantly recently. Sycamore is here, which is also very similar. But good old Dioxys is down in like Preact range. Yeah. I was going to give Dioxys an, as far as I can tell, it's slightly behind Leptos. So for my tier listing, I was going to give it a B. Maybe this is not fair. Maybe this is incorrect, but this is where I was going to put it. Greg says that it's an A. So should we trust Greg? I don't know. Maybe. Greg knows what he's talking about Rust more than I do. Fine. Greg, you've convinced me. It's going to be an A. It's possible for the old version. This is my list. This though, in a sense, is this. Do you know what I mean? It's solid a million, but in Rust. It's happening right here. Okay, this is React compiler. Fun one. Where does the React compiler go? Raw rendering performance. This isn't about the code you write. This is about just raw rendering performance. Yeah, I'm gonna. I think this one's gonna be fun. For all you guys saying D, why are you saying D? Same as React, yeah. Yeah, I did give them too much of a hint. Yeah, it's a D. React compiler writes really good React code, but if you what happened to the, did I crop it by accident? It lets you write really good React code, but it also doesn't really change much. Similarly, if Qwik, a VDOM with signals is here, you can guess that Preact with signals is also still a C tier. It doesn't change the quality of it. Have you noticed to go from C to B has almost requires compiler interference? Going from B to A has required dropping the VDOM for the most part to either a block DOM or a reactive thing. Inferno is just so optimized that Dominic somehow changed the math. Yeah, just kind of putting that out there. Yeah, so yes, the React compiler doesn't change anything. Yeah, benchmark code is already written in an optimized way, exactly. It just means you don't have to write the optimizations of your dev. That being said, if you look at the optimized code for frameworks that aren't called React, you'll find that or like the non-re-render frameworks, you'll find that, funnily enough, the basic code is the optimized code. It's an interesting thing that we started noticing is that the idiomatic code for Solid was the optimal code, where the idiomatic code for React was not the optimal code. It's interesting. I mean, the million.js that goes in the benchmark, people use million in React, but it's not React doing the rendering. So I don't count million as like in a sense, million maybe doesn't belong on this list because Aiden didn't really want to make a full framework and push it. But like there's basically nothing it's million is more like a parasite that lives in your React app. Like there's nothing about the part that million does that is React. Zoneless, Angular, or not yet. No, I haven't talked about it too much, but zoneless is enough to bring Angular up a tier into like the C range, and maybe even B. Historically, zoneless has been C, but then Angular's been working on stuff like control flow. Like if you look at the new Angular stuff in the last year, a lot of experimental stuff, Angular's actually up into the Bs. But generally speaking, even zoneless on its own it's basically a tier level thing. There's so many different modes of Angular that for the most part, historically, when people just go and test stuff, like at a base level, Angular and React have been lockstep. So we got two left. We got Svelte 5 and we got Vue Vapor. Yeah, I mean, people kind of can guess where this is. Where does Svelte 5 go? I already kind of revealed this earlier. Svelte 5 is S tier. Svelte 5 is not any slower, really. Svelte 5 and Solid are basically identical. And it's because they are also very identical, like very close in implementation. It's signals, it's fine-grained rendering, a lot of the stuff that we talk about today. It's, as I said, we started with reactivity and we're back here, 15 years later. Vapor, I don't know where Vapor goes because it hasn't been released. Vapor in Evan's original show was S tier. In the current benchmark, it's A tier. I'm going to be an optimist and stick Vapor up here because I trust the Vue team does good stuff and that it will get there when it gets there. But this is sort of the scenario. The only thing that it is is interesting kind of pointing out is the time period when we first started putting these on our tier list, like when we like from 2010 to 2014, we had maybe 5 of these, right? From 2014 to 2018, we had 24 of them. And in the last, or maybe 22 of them, and then in the last 8 years, we added on like the last 8, so to speak. So like there was 8 years, or there was 7 years between Solid's S tier and Svelte 5's S tier, like in terms of timeline. There was between Inferno going to A and like anyone else even getting above B was like 3 years. So yeah. S tier second position, that's million JS. But that is my completed list, I think. We can shrink this down a little bit, blow it up. But okay, this is how we start. Yeah. Next.js isn't, from a client rendering perspective, it is the same as React. Yeah, so yeah. The funny thing about this is this table starts showing you how Svelte 5, Solid, Vue Vapor are here. Preact with signals is here. And interestingly, React with signals, or Jotai, is still down here in D tier. A framework with something additional is never faster than the framework itself, right? And it's part of it is because you're not mechanically changing how the framework works. So we're going to talk about mechanically how the frameworks work, right? It's a very negative way of looking at things, but in this vector, yes, not no improvement. There have been improvements over time. This is yes, it's. Actually, you know what? I made React purposely the anchor point, so React couldn't improve unless they did something completely drastic, and that's why they were a good anchor point. React has improved over the years, and everyone else kind of next to them has improved over the years ever so slightly, but because React is such a stable anchor point, it was easier to show like when other things make bigger jumps. So React has gotten better in 12 years. Sorry, that wasn't fair. It's just that like, yeah, Solid 2 will still be in the exact same place, or so I hope. Performance is not what I'm chasing anymore. In terms of, I want to make good performance and find good performance in different areas, but in the past 7-8 years since Solid's been here, we haven't meaningfully moved beyond this model, and I don't know if we will anytime. Even Dom said it back in 2016. He thought he was done, and to be fair, with the browsers improving the way they have, and I'd say Inferno is like more S tier than this might show now. He was done. He's like, performance in the browser is a solved problem. In he said that back in like 2016. He's kind of right. It's just taken 8-9 years for everything else to catch up. So yeah, I'm not expecting Solid to be like way faster here. It's just, you know what I mean? Like, Solid's been that fast. It just meant I haven't had to worry about performance for 8 or 9 years. I've been working on other stuff. That's the question. I don't know if we have an approach that's better than this in a significant way. We've gotten very close to like vanilla JS. There's still overhead and over time I expect it, but we're really, the 80/20 rule, we're at like the 90/10 rule at this point. Like WASM could get uh uh maybe see that's the thing. WASM could, without Leptos or Diaxis changing their code, could cause a change to happen here. But all that can happen at this point, I think, is either through the browser or work of the stuff that the frameworks kind of get more up into this S tier area. Imagine solving performance and then resting for 8 years. Well, I mean, what Dominic tried to do was to go and apply his knowledge to other areas. That's why he gave up Inferno, because he's like, yeah, I did it. He's like, okay, can we make React faster? And that wasn't where React was heading. And then he's like, can I do lexical, right? And then he came back and he's like, guess what? I can make Svelte faster. And he did, from Svelte 3 to Svelte 5, So, yeah. I mean, meta frameworks are overhead, but it everything's an overhead. That's why when benchmarks, you focus on a specific thing, right? Your actual site's performance is going to be based on your actual site's performance. These are only indicators or things that can help. They're not the reality. Make it solid faster to make it more fine grained. I don't think so. That's actually the hardest part. Could have made solid more fine grained, but it was actually more expensive. Fine grained versus not has a creation versus update trade off. And what I started learning was that loosening granularity was the key to performance, because you spend a lot more time in creation on certain types of tasks. So yeah. Okay. Ryan, place Marco 6 in this tier list. It will allow this one time for fans. Marco 6 is also S tier as far as I've seen it. I was working on it. It was up there with Vue Vapor install. It's the same signals fine grained rendering thing. I think anyone who solves, see, that's the thing. I think Solid's more popular with framework authors than it is with people. I think anyone who understood how this stuff works and saw Solid was like, yeah, we're going to get there. It might take a few years, but we're going to get there. Angular's in that boat, Vue, Svelte, Marco 6, definitely. Next year, see, that is an interesting challenge, right? Because the only library up here that can get, like, to be fair, Solid's approach without a compiler is also S to A tier range. But the only one, here you go. I know you're a web component guy. I'll give you a little highlight. Lit is sitting up here. When you consider like the compilers and all the stuff up here, Lit is sitting here as a non-compiled solution, surprisingly high. Now, Lit versus Solid without a compiler. Solid without a compiler is still faster than Lit. But people use the compiler for the ergonomics. It's worth it. But Lit does pretty well leveraging that type template literal approach that I talked about earlier. So it is a bit of an anomaly that's worth shouting out. Fine grained as a snippet of yeah, I mean, I've seen it when applied in a specific scope where you've tied the data to a specific thing, like Mikado in the JS framework benchmark. But I think someone's gonna have to prove that it works in a general sense. My experience here has been that because of the different types of operations that are possible, that ultimately the complexity ends up catching up with you and it ends up not being faster. It's funny because MobX actually had a really good fine-grained array approach, and I was trying to make my MobX port of DOM expressions use that instead of my map array to see if it do it. And again, I switched to my map array diffing approach because it was still faster. So that was like 5-6 years ago. Things could have changed, but generally, and maybe new techniques discovered, but generally this hasn't been proven to be the case. And it has nothing to do with real life use cases. This is just me doing benchmarks. Million JS. I have not had a chance to look at the alien signals yet. I've been spending a lot of time working on updating Solid's renderer to using lazy rendering, which is actually a big influence for the topic of today, which we should get into. Am I planning to discuss state management libraries? Not particularly. Only thing to know is when you take a framework and you add a state management library to it, it makes it slower. It makes it easier to write optimal code because a lot of people do dumb stuff. They do easy stuff, and that state management lets you, like a VDOM, like React, lets you like actually drive stuff from the outside. But if the same updates could be applied, like if the framework can render something that way, then it's possible for it to render that way without the state management library. So if you could write your code in that way, it'd probably be terribly unergonomic. You would get the same performance core characteristic without the overhead of the state management. So generally state management is for your sake, for your sanity, and not for performance. Okay. Why do you need state management when it's built in? Okay. All right. We let's, now that you guys have your appetite whetted, so to speak, let's get into the fine grained rendering. So let's start from the beginning. And by start from the beginning, I actually, you know what I want to do? Give me 2 seconds. I'm going to open my drive. I want to pull something up here. This will just help me get started here for a second. Solid Talks. The world beyond components. Doesn't really matter which version, I suppose. I want to start exactly where like my intro talk to Solid ends, so to speak. And yeah, I haven't done this in a while, so let's see if we can open this up. Okay, we'll build up from here. I'm gonna assume that most of you understand how signals work at a core level at this point. And we're gonna basically apply this to rendering, okay? In fact, I'm just gonna call it render effect from now on. It doesn't matter. It's basically the same thing. We're gonna console log. So this is the example that I always used to show when I was doing like I'm gonna actually jump one more stage because I don't care about doing this. I'm gonna go right to here. Okay. Essentially, I have a signal. I create an H1 element. It's a DOM element. I create I'm going to make this a render effect. It doesn't really matter. It's basically the same thing. Create a render effect. Set the text of that DOM element. And then create a button. Give it some static text. Add a click handler to update the signal. And then because of this render effect, every time I click, the text updates. Right? You guys have all seen this before. So the reason this is always so easy to show is because all you're doing is essentially assigning text to a single text element, right? And it's also really easy to show. I've done this a bunch of times, and I'm going to do it really quickly right now, although I will go back, make it a thing, is that in Solid, we can just go button and go, okay, well, it's a JSX element. So button with, I'm just like basically line by line going, okay, text content is click me, and on click handler is this. Like, it's not hard to picture how we can go from something that looks like DOM stuff to something that looks like this, right? I'm just saying that this compiles into this, essentially. It's just an effect, or sorry, this is not an effect. It just creates an element with a click handler, and this one compiles into const h1 equals h1, and we put some kind of expression in it, which is, well, actually, we can just put this expression right in it. Makes it easier. And then we get rid of this. This compiles into this, essentially, where it knows that this whole, where you have an expression, it goes, okay, this has a function call in it, making a render effect. We do this, our demo still works because we're just creating an element, creating an effect that renders the one piece. Everyone can visualize this because you're just doing this one kind of simple, fine-grained update. And then usually the next thing I do is I wrap this whole mechanism into a component, right? And I call it counter. Okay. And if I take my elements from counter and let me format this a bit and have them be returned as an array of h1 and button, and then call counter here and spread it in as the arguments, again, still works. And then, instead of doing separate variables, we inline the array. I imagine almost everyone who's familiar with my work with Solid has seen me do this demo before, but just bear with me for the people who haven't, because this is fundamental. And you're like, okay, do I need an array? Well, let's just make the array a JSX fragment instead of an array. But, if I format this, we have something that looks like a React component, but it literally just has this one create effect here, and it created a bunch of other DOM elements that it just appends to the document. Okay. Usually what I do when I do this demo is I jump ahead here and I go and I create a version of the demo where I actually have multiple counters. And essentially I show console log here, although see, there's something the Playground does, and I don't know why it does this, and Milo or someone's gonna have to tell me, but they dedupe console logs for some reason. See how there are two of them? There's only one here. I have no clue, drives me nuts. But the point is, after this point, whenever we click a button, the component never re-renders. It's just this one effect that listens to that one signal, right? Because we create two functions, two separate closures, two separate components. These act completely independently. If we didn't want them to act independently, they could reference something from the same spot. We can lift them up, pull them top level. Guess what? Global state. Now they're both the same, right? Because they're just sharing the same instance. There's nothing magical about this. It's just the rules of JavaScript functions, closures. It's simply you just construct stuff. Yeah, preactively. Well, the reason is like fragments are special, which we'll get to in a moment, because they're actually the core of where the rendering problem gets in. Because it's not hard to picture this scenario, right? This is basically solid. Very fast version of that demo, but you get the gist of it. Is these? I mean, you can actually see it in the compiled output here. You'll see like basically there's some templates that are just like creating elements that get cloned, and then you'll just like if you look at the actual code for any of this, it'll be like clone the template, walk into the client, and call this insert call. I'm going to show you what this insert call is, but it's basically just an effect that updates the text in that text node. And but the core of it is a simple idea of that you just create some elements and you update the one thing. There's no like framework. Like this didn't have to be a component. We could have just called the function. Mostly. Okay. So that's the gist of the demo. I think I do one last version to really nail it in. Which is I hoist up the signal. Instead of putting it in global scope, I put it in a parent scope and then pass the value down as normal and then the value times 2. And then I pass down 2 click handlers, which then get applied to the button here. So like one adds 1 and one adds 2. And then one shows the count and one shows the count times 2. So they're shared state, but they have different handlers and different like prop values. And the key part again is because the only effect is the one that updates props.children here, even you see there's a console log app and a console log counter, even though it like looks like we're accessing values here and stuff, like while we click, there's no more console logs. This one goes up by 2, this one goes up by 1, this one times 2's it. Nothing here forces the component to re-render. And the reason is that we defer evaluation to the very end of the chain. We know that if something calls a function or has a getter, like could be a getter, like a property access, that we need to make this an effect when we're talking about components. Or sorry, when we're talking about native elements. So it updates the thing or the attribute. But when it's a component, the exact same heuristics tells us, hey, this could update. It's a function call. So it wraps it in a getter. What we'll see here is we have create component counter, and then get children is actually a getter that calls count here, which means that it's a function call. We turned count times 2 into a function that gets called inside our effect. We basically just pushed everything downwards. We don't need to, we just created everything. But then when we update it, it's only the effect that goes, oh, run this effect, call that function, which calls that function, and it gets all its dependencies and it does its update. We don't have to reconstruct a tree in order to update something. This is the easy part that people understand about fine-grained. It's very obvious, because if you did this in React, even with the React compiler, although the console logs would try and be smart enough to fool you, this scenario, when you set state in this component, forces this component to re-render, recreate its VDOM. Now, the compiler is smart enough to go, oh, some of those nodes I don't need to recreate. But generally speaking, it will always rerun this. And it goes, oh, has something below this changed? Then, sure, it skipped the thing that has nothing below it that changed, but it still has to then go into here and go, oh yeah, maybe this one counter depends. And in this case, it's both of them. And go in and re-render this. It's unavoidable from a top-down structure that even with the craziest memoization, you need to execute, because if something changed, you can't just stop. You have to go, oh, what has changed, and go down and down and down and down. You can stop if you know for sure nothing below this point has changed. But if anything has changed, you have to run everything in between the change that happened and the impact of it. We're doing the same thing in the sense that we are running everything in between. Essentially, when you update count, we are rerunning this function that we wrapped in the getter. we are rerunning this effect. We are running all the way down the chain. It's just a separate stream of like a separate channel than the components. The data runs through your components rather than is your components. Right? No. Just a side note, not easily. Okay, so I hope everyone's following along so far, because this part of the demo is usually the fairly straightforward part of the demo, because if you understand signals, you understand that you can put as many functions as you want in between. I'm hoping that makes sense. I mean, it goes back to our initial, signal and effect. If I go back to something like this, not even this one, if I go back to the very first one, where we have a signal and an effect, if I decided that I'm going to have, double count just be some getter or some function in between, count times 2, and I put this in, I didn't break reactivity, right? I see 0 and 2, when I set the count to 1, it's always double it. If I set, if I set the count again to 2, you see 0, 2, and then 4. Like, my point is that, like, yes, you can't destructure, because destructuring would be like getting rid of this function. Destructuring would be like doing this. Now this isn't a function. We access the signal value, and you accessed it once. This effect never updates. It doesn't even run twice now, because it doesn't depend on a signal. It literally depends on a value. You said the count is 0. When it runs, it does not track count. Count is out here. In fact, ESLint is yelling at us. This reactive variable count should be used within JSX to track scope, like create effect, or inside an event handler function, or else changes will be ignored. That's the trade-off. If you're going to make a channel through your app, the channel has to exist. Yes. Yeah. Sorry. I'm going to use solid in my examples here because I'm most familiar with solid, but Svelte 5 was basically designed to be the same. Derived is interesting because it can do what Ryan had pointed out to be the problem in solid. Not really. You're talking about the fact that derived has this as syntax. I mean, if you look at the compiler just adds the function. Syntax to remove compilation stuff is convenient, but it doesn't change what it is. And another great point, you can solve destructuring by knowing that something's a component. We have a library that came out about 4 years ago in Solid, Solid undestructure or something. I mean, Babel plugin Solid undestructure 4 years ago. People have come up. If you have a way of saying, he looks for types or like denotions, if you have a way of saying something's a component, you can completely go and make it destructuring work. The problem is it's a lie, just like the lack of function in the derived example I was showing here a moment ago. Like, yes, this is more ergonomic, but the second you do something else, like it isn't component props, instead you created a higher order primitive, or composable is what I think they call in view. It's like, oh, now you can't destructure again because you built something in a different scope and you pull it in. This is was the Svelte 5 problem that they solved by adding classes, by giving it a blessed way, but it's still the same problem. If you use a ruin in a different file and you try and pull it into your file, you have to wrap it in a function or have the compiler automatically wrap it in the function. But conceptually, it needs to be wrapped in a function, and conceptually, you can't actually destructure. The compiler can reverse it, the destruction for you for an ergonomic standpoint, but it's also kind of like not what's really happening. The compiler just gets rid of your destructuring and then accesses it where it needs to be accessed. It's nice until all the edge cases where it doesn't work. Yeah, Svelte did that with $sign props. Yeah, these are all. If you read my article about complexity, these are all. These are all like it's like the perfect example of adding complexity for ease of use, because it's like you're not fundamentally changing what it is, which means that there's like tons of edge cases where that doesn't actually work, but it makes like typing it slightly easier. But then like somewhere else where you actually can't destructure, you're suddenly like, why is this not working? And it's like you might not even, if you're a new user, you might not even realize it because you thought, oh, I can destructure here. Why can't I destructure here? Well, it's because destructuring does not actually work. We just kind of lied to you. Nope, stores don't solve destructuring either. Because the stores are still a getter. The problem with destructuring is you're calling the function too soon. Right? This is one of the interesting things, because I have some pressure, just on a side note, from like the DX team. Because we I don't know if people know, Svelte runes or runes. We had a very similar same syntax released as a library for Solid 4 years ago. So you could have the performance and the syntax of like Svelte basically 4 years ago. But I never pushed it because it didn't align with our transparency thing. Like when possible, we try to make things the way they actually are rather than hide them only for it to break somewhere else. And it's fine for different frameworks to have different priorities. So I get why Svelte's different, but it's it's probably just worth noting to people, because as I said, the DX team sometimes wants to be like, we should just like go put that everywhere so that, when people show Svelte examples, we can show solid examples that like look the same and have the same less syntax. And I'm like, I mean, go ahead, but like, we're never going to spend as much effort into it as Svelte does because they care about that. I don't care about you writing less characters. I care about you understanding and, not being confused. And like, it doesn't really get us anything because it actually suggests that we find value in it, which we don't. It's okay if others do, but we don't. So yeah, it's a tricky balance because the libraries do exist. I mean, you should probably just go use Svelte, if something like that's really important to you. But just so it's out there and people know, or view. We've had the ability to have the same syntax with all the solid performance benefits and all that for 4 or 5 years now. It's still there if you want to go use it. It just really doesn't matter. Is there a language level subject restrictions? One of the most. No, it literally just doesn't make. It's because the only. No, yeah, there's. Yeah, this is just not. This is why I'm not a huge fan of the compiler approach to this, because it's literally something that can't be solved. So we're just lying some of the time for something like, you know what I mean? It's yeah. People used to talk about the React just JavaScript, but Solid's arguably closer to that than most other frameworks. Yes, I think we've taken the just JavaScript mantle now, for at least unless you get into like this no build zone. Anyway, okay. getting back to what I was kind of getting at here before we were talking about the destructuring and stuff, is there is this transitive property of functions, right? They run through your whole app. This is the foundations of fine-grained rendering. It's Knockout.js had this, Vue has it, but to the rendering point, actually, Vue doesn't fine-grained render like that today. Vapor will have it, but Svelte 5 has gone this direction as well. Essentially, this, even Preact technically and Qwik technically have what I'm showing you right now. They have the ability to update text nodes directly without re-rendering the VDOM. This is kind of like the baseline of fine-grained. And the problem is we stop there in demos because then people get it and they're like, it's not React. And then everyone assumes that Preact signals is like solid, and then they see like a benchmark where signals are faster in one library than the other, and then they're like, oh, that must mean this other library is faster than this other library because its signals are faster. And it's like, no, it actually has almost no impact because they don't actually render. You sped up the signals and now you're re-rendering the whole VDOM, so let's talk a bit more about what happens after this. Yeah, I mean, if you had a different language feature that instructed it somehow, like a decoration of some sort, like I'm not going to say anything's not impossible. I'm just saying JavaScript does not have the syntax or capability to, like, another question people have is, like, instead of having signals as a function, can you have it just as a value? Like what Svelte compiles to? Could there be the idea of atomics? I think that's interesting, at least because within a local scope, having like a getter that way could work. It wouldn't be transferable though. The second you actually tried to get it out of that file, you'd have to wrap it in a function again, which is why the TypeScript problem of functions not being able to be stable with signals is so important, that I've been talking about, because it doesn't matter which framework you have, whether you use dot value like Vue or you compile it with Svelte where there's no function call or whatever, or you're solid where you call a function or whatever. Ultimately, with these reactive systems, functions carry reactivity, which means that at some point you're going to hit the point that calling double count, like from a TypeScript perspective, I know I'm jumping around a bit, but if you go like if double count is nullable, essentially, and you access it in here, TypeScript will complain at you and be like, sorry guy, we don't know that it's not null, even though you just did the check because you called two different functions. It's not stable. Functions are at the core of signals-based reactivity, whether they're hitting getters, dot value, proxies, whatever. Everything is a function. It's it's a different type of functional programming. Will native signal implementations will solve this? No. I mean, the native signals implementation is still calling functions. Ultimately, there's no language level feature that gives us, avoids everything being functions. Yeah. Anyway. Where to go from this? So you can clearly see that you can like chain a value. So it doesn't have to be a basic value. You can pass it through props in components, like we showed, not here, sorry. We can pass, actually, yeah, it's this one. We can pass it through props through components, and we can basically create this like super hyper updating thing. So if you have a DOM element, we can make sure that we do the least amount of changes. It's kind of obvious why this happens, because we keep all the update channels isolated. It's like memoization, except it's not, because it doesn't run any of the stuff. Memoization goes, okay, this branch is good, this branch is not, but it can never get, it's almost impossible for it to get granular enough, because it always has to have a starting point, which runs it downwards, where signals are events. So they can wake up at any point in the tree, regardless of like some kind of, framework concept, like a component. Because in React, state is tied to the component. When you update a signal or like your state in that component will rerun. That is the fundamental rule. It doesn't exist on its own. It's not its own event emitter. The component is kind of the event emitter. So a fine-grained system separates the UI from the data, which is not a new idea. People were doing this back in the day, when they had like MVVM or MVC. And some people kind of go really hardcore on the other side where they're like, let's, pull our models out here, our views here, keep it all clean, separation concerns. I'm not suggesting that. I think actually the overlap is very ergonomic for modularity and encapsulation. These things do roughly coincide with each other. Don't keep all your state here and all your UI over here. Put them together. Just recognize they're not the same thing. That's the fundamental pitch with, reactivity and signals with rendering. But we need to do more than this. We need to do more than just put a bunch of components on the page and update a bunch of values. As I said, if that was the end of the world, end of all we wanted to accomplish, then you can see this as pretty straightforward. The first place where we start hitting challenges, and I'm going to keep this counter component because it'll just make our life a little bit easier, I think. I think this is probably where I want to stick it. This one's still working. Yeah. Okay. Yeah. So I think I'll use this as a base. I'll get rid of some of these other ones. Is what if we have a decision? Control flow is the thing that Qwik or Preact does not have. If you need to go branch A versus branch B, it's a VDOM re-render. How do we do control flow when we are using the signal system? Because so far everything has been one-to-one. There's no decision, right? And the easiest way conceptually here is if we have a decision. I'm going to make a decision component, let's call it. And in our decision component, it's going to have a signal in it, okay? And the signal is going to be show and set show, okay? So just a Boolean create signal, okay? And we're going to start it to true, okay? So we know conceptually that this is going to make a decision for us. So we'll think to ourselves, okay, like if show, then I guess we need something to show. So we'll be like, if show props.children, otherwise let's return null. Okay, so this might be what we kind of first think about, right? Actually, I'm gonna make it an empty array just for the sake of this. And what I'm gonna do is actually, do I want to use GSX? It doesn't really matter. It doesn't need to be that. I'm just going to make it like children as a function. I might decide against this later, but essentially, instead of calling counter now, what we're going to want to do is we're going to say, can we take decision and we're going to make it a function, I think. See, if I use JSX, this would be more clear, but I also want to really illustrate it. This function for children is going to be return counter. I guess counter is a function already, so I don't need to do it. I'm just doing this to spell it out. I hope it's clear. What I'm suggesting is we're passing this children function to decision that says render this counter component. So the concept is if show is true, then it renders children, otherwise it's not. And if you look, our counter still works, right? This is a very basic show component, essentially, where the problem is obviously we need it to actually be able to control the decision point. So let's create a button somewhere. It doesn't really matter. I mean, we could create a button in here, but I don't want to. I don't want to muddle it too much. Let's just make the button out here. Const button equals whatever. We'll just use JSX as a short form. It makes it convenient. But button on click, and we want it to toggle the set show essentially. So I could hoist it out, but I'm going to leave it in for now. We're just going to have a function called set that goes set show equals that. And put it out here. Okay. And then on click, we're going to go set. And this is Solid's function syntax is basically not set. Okay. And this, sorry, it's a function. Okay. Hopefully you guys are all are still following at this point. Right? I'm doing this very basic right now. TypeScript's complaining this doesn't exist. But you can see that it's showing and it's updating. And then if I add button to our UI now, oh, I got to get the button some text. Button, let's give it toggle. Okay. It's there. I click toggle, nothing happens. Yes. This is what I was talking about earlier with the components is the onClick is a function handler, so it should be, but we turn functions or expressions into getters. We turn them into functions essentially. Like, yeah, I closed the example down specifically, but this is a good one here. In this example where I pass count as to the children here, Solid changes children to a get children function, returns that. You access it by just props.children, but it turns it into a getter. So count does not get called until you use props.children, which is inside this effect over here where it goes passing a function that reads props.children, which is actually this right here, props.children. This is technically calling this function. Yeah, it's interesting though. Thinking around these are more interesting because if you start having a problem with argument order though, right? Like which prop is first? If you could denote a component as being the thing and argument order didn't matter, like so that you could pull them out in any order essentially when you authored it and you didn't use an object, like it's interesting. Then you wouldn't even need the destructor because destructuring wouldn't be a thing. You wouldn't think of it as an object. But anyways. But also objects are good because shapes change. You can spread props into JSX, which means that the shape of the props can change over time. You can send some props and then send other ones, different ones later, which means that like destructuring has its place because the arguments can change. Yeah, this is the answer. There's a question that goes, about all function calls or only reactive ones wrapped? No, all function calls. We can't tell the difference. Yeah, the compiler wouldn't know. This is a very, very simple heuristic. I mean, I guess if you force every user to use TypeScript, maybe that's more and more of a reasonable thing. But I built Solid.js in a world in which you could not say you cannot use my framework without TypeScript. Built for JavaScript. And anyway, yeah. So getting back to this, why does this not update? Well, it's because you can see it. ESLint's already telling us we call this function once, and we're reading this, so there's no way for it to update, right? So the only way that we can have this update again is the same way we've always had it update again, which is wrap this in a function, right? The interesting part now is because now this can change, like because it's wrapped in a function, it has the ability that when to rerun this piece if show ever changes. This is actually how JSX and Vue works. If you've ever seen it, they always return a function for the whole thing. In Solid, we don't return a function for the whole thing. It's more granular, but it's the same concept that you have to return a function for control flow, because otherwise it could never change, right? But if you think about this, this is not a terrible thing because this can only change between true and false. So when it's true, it renders it once. When it's false, it goes to this branch once, and because it can only swap either or. You're not doing anything wasteful. If someone changes from true to false, there is no choice but to switch. But now we have an interesting problem down here because we can't just spread our stuff into here because now it's a function call, right? Before it was elements, but now it's a function call. So what do we do? Well, we have to like get away from this and we have to actually build our render function, so to speak. And it involves having this mount element, right? We know we need this mount element, the app element, but instead of appending it, we do what we always do. We create a render effect. And const L, or mount, let's call it mount, is going to be our main element. And now, instead of append, I'm going to say, let's do replace children. It's the same API, but it just replaces everything. This is a very rudimentary look at rendering because you don't always want to just swap everything out. That being said, if you pass the same element again, you're not necessarily recreating anything. So it's not the most inoptimal thing I can think about. The idea here is we're going to basically make an effect that puts this stuff in. Now, we have a problem here though, because decision, which is like our code coming in, like maybe it would help to actually just call this function render for our sake, and then what do you pass to a render function? You pass code and you pass the mount element, right? And so let's just do this. Okay. So, oh, actually, sorry, my bad. It's more like this. We're going to render our decision, and we're going to, our render function is going to have a create effect that is a mount replace children. I'm going to keep the button outside of the rendering. I know this is kind of odd. Just we'll do something about that later. We'll take our mount element and then we'll render button, and then we'll split in code, okay? And the problem, as we already hit here, is that this code is a function. So we might do something like while type of code equals function, code equals code, right? Now we're going to just unwrap it, right? And then we'll do this. Now, what? My guess is I have another bigger issue here, which is why this is not compiling at the moment. Oh, there's what's going on there. Did that work? Children is not a function. Oh, because we didn't pass our children in, which was, what was our children? It was I'll just put counter and you guys know it's counter function. Can't access button before initialization. Is that a TypeScript issue? It's kind of funny because this button is here. It's not, isn't, that is a little bit funny because it, oh, do you know what it is? Dumb me. You have to actually instantiate it before you call render. All right. We did it. Okay. Up, toggle. Oh, still not working. Why is it still not working? Yeah, sorry, chat. You guys, it's like slight delay. S here is just the functional form of like the previous value. So it's saying like set show, it's going to be true, and then we're setting it to not true. All right. So why are we not getting it? I guess the first question, see, I told you this part might be a little bit rough because I haven't done this for console.log. Let's see if we're actually pressing the button. Because this one still works. This one is pressing the button. So we're setting S to not S. Okay. Which should trigger format. Yeah, I mean, we are, in a sense, this is the baseline here, because what should be happening here is that when this runs the code here inside this render effect, well, it's a type of function, it's essentially going to get a dependency on essentially on show. And when we set show from true to false, you know, let's just for fun, let's just go set show false. It should now, when the effect runs again, see if we go console.log effect. See, it runs again. Well, I mean, we can see what it gets when it runs again. Okay. Interesting. Because it's actually saying that it's still getting the array when it calls code. Which is, okay, let's rewind, toggle effect, HTML changing, toggle. Effect runs second time. Let's do this. Haha. It's not running decision again. That is interesting. Oh, do you know what it is? I'm such a dumb. I named my variable here the same as the variable that comes in. Um, yeah, okay. Sorry about that. Um, let's let's just make it like some local scoped thing. I'm pretty sure this is the problem. It's like we're rewriting it so it never tracks again, is my guess. Um, oh, I hate when this happens. I froze my browser. Oh, this is actually really annoyingly bad. This is this is the one downside of using the playground, because if I don't save the spot, it's an infinite loop. Yeah, I can't change the code because I froze it by creating an infinite loop. Quick, memorize it. See, I can't even select the code. The debug tools are frozen. Other, yeah, yeah, it's just gone. The funny thing is, this happened to me during front end masters. Bam. Oh, that that is so sad. That is so sad. Okay. Okay. Yeah, it like kills the whole process on that thing. Okay. Um, let me get the right example out again. We'll just keep the counter. The screenshot exists in the stream. Yeah, because essentially what I was trying to get to here is that um, code. Hmm. Mm-mm-mm. That's funny how everyone's chat telling me about the screenshot thing. Uh, add some typo first to prevent the infinite loop. Yeah, that's usually helpful. Function equals function, function equals function. Hmm. Sorry, this will take me a second to recreate it. Function, and then mount dot replace children. All right. let's just get the render code working in the basic case. Document dot get element by ID app, and let's make it, let's start with just making a counter again. And then let's make our just show component, or and then call it toggle. It's more effective. Show, set show, signal, return function of show, then return. So now I'll keep doing this way. Children. And then toggle. And then add the button back. I'm like trying to decide if I want to add the button back the same way. The reason that it's a bit of a pain right now is because we can't right now we only understand functions. We don't, and we assume arrays. We're gonna need to do more than that in a minute, but to get started, I just wanted to show the function thing because it's simpler than handling multiple arrays. I could stick it in here, to be fair. Right, like there's nothing to stop me from doing button like here and put button here. And then essentially const button equals button right, I gotta spread this. And then toggle equals on click set show not s toggle. Of course, you need to put in a function wrapper, format it. Okay. Click, toggle, click, toggle. Okay, sweet. All right. So, is foo better than foo? No, it's just I haven't shown you guys that. All I've shown so far is that fragments produce arrays. The fact that fragments produce a function, you should wonder about at this point, right? So, okay, we're back. Essentially, we made our simple control flow component that toggles, and as you can see, control flow itself is just another function. But what it means is that it isn't enough just to have an effect. The effect that does the rendering, that does the inserting, like when you have an attribute, you can just go give me the value and set it, like set the text content on this div. But when you're rendering arbitrary stuff, like this is what the insert function is essentially. I called it render here, but we are basically creating the insert function right now, the one that I showed from the compiled output, is it needs to actually understand that there are functions in the chain, because any decision point at minimum has to be referenced by a function. Like there's no other way to do it, right? And what you're going to notice too is that when I click the 7 and 8 and I toggle it off and then toggle it on, we reset back to 0. And the reason we set for 0 is because essentially the state is being created in that child component. So when we remove it, we're actually removing the state with it, right? If I hoisted the state up here, global state, then when we toggle it and bring it back, the state will be preserved and we'll be able to continue it, right? So this isn't too much of a revelation, but it starts imposing some of the restrictions you have to think about when actually doing fine-grained rendering, because it's not just about pinpoint updates. You actually have to reduce code down. And at the point of render into an element, it's fairly straightforward, because let's do something a little bit more fun. Let's make our function, because this still works, toggle. Let's make our function actually toggle a toggle, right? So like this. I think I got that right. Toggle children counter toggle. What did I do wrong? Because toggle returns a, because I shouldn't need to though, because the toggle always returns an array. Oh, it's because this one's not an array. Thank you, Dev. Took me a second. It's because that one's not an array, right? Which means I need to spread it in, I think. Yeah, doing this with arrays is already starting to show like some of the complexity here, right? Because we also need to understand arrays, essentially, because I don't want to have to try and force, because when toggle comes back, it's a function, so we can't spread it yet. And then this, actually, let me think here, because toggle, we call counter, toggle itself returns a function. And then we call toggle on a function of a function. The problem is this is what's killing us, because it assumes, this is the problem with adding button here, because we're already getting into fragments. Fragments are tricky, because when you have, it's fine, we can go here. I wasn't ready to go here, but we can go here. When you have a DOM element, this is actually exactly why I wanted to bring the I'm gonna cheat. We're gonna get rid of fragments really quickly. I'm gonna make that a single element. We're going to make this null. We're going to make this a single element. Yeah, I am going to shamelessly cheat, because I don't want to get to fragments yet. It's too complicated to where we want to be right now. We just need children. All right. Oh, see, but this is cheating too much because I'm basically building my own render function here, right? You see what I'm doing? Like I'm creating a div and I'm cheating too much. Okay, see, this is the problem when you don't think out these examples far enough. I had the right idea originally where I hoisted the button out. All right. But then if I hoist the button out, it's going to be like increasingly a pain to to show the composition here. I mean, it's fine. You're right. I am trying to get there in a specific way. It's hard. I'm trying to find like the baby steps way of getting there. Um, but it's difficult to do because there's two big kind of mental realizations that come in this zone. One is that um, everything that's a control flow has to be a function, even like nested. So you end up with functions of functions of functions. That's what I was trying to show. Like if I forget about these buttons for a second and just like after the fact here, you know, like go set timeout. Actually, I don't even have to do it after the fact. What's the problem here? Code, return function, show children function. This is fine because it's an isolated, so there's no function here. It's just a node. Children is a node. Calls a function, returns a function. The funniest thing is I feel like I'm missing something that's like console.log function. I'm like missing something that's like, yeah, so it's a div element. That error is not helpful. Maybe if I open it up here, I can see it better. It's one of the spreads I'm doing. But I'm only doing one spread. Oh. Get rid. Yeah. 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 Thanks, Dev. Yeah, you guys got me. Thanks. Okay. Okay. Sorry. What I'm trying to get at is you end up with this scenario that looks like essentially like a function that returns a function that returns a function and so on, right? And initially when I was creating solid, I didn't know what to do with all of these. I'm not going to lie. While this seems kind of safe enough to begin with, you end up yeah, okay. Yeah. This is actually going to be better now. Go const setters equals an array setters dot push set show. Okay. I mean, this would be even nice. I think I can start with two. I'm just trying to think of the best way to show this because the 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 problem, and I'm actually going to put setters equals this here, because the problem that we're going to hit in a second here, and I'm hoping people will see this right away when I actually do it, and I'm going to make two buttons, const button 1 equals button on click setters 0 s not s toggle 1 slash button button 2 button 1 button 2 I did the same stupid thing again. Learn better, do it before the render. Okay. Okay. What I'm trying to get at here is, oh yeah, and I should change the text here is, and I'm going to console.log toggle. So toggle, oh yeah, this is, I told you that the fact that it doesn't show all the console logs is really annoying. Toggles twice. Now toggle 2 is the closer one. When I click toggle 2, oh, it's funny, it's not even working, but no matter which button I'm clicking right now, it's actually, well, this is what I actually wanted to show, but I wanted it to actually be functioning as well. But whatever button I click now, both toggles are getting called, right? This is React re-rendering in a sense, like it's the whole thing, and ideally we should only toggle the ones on the inside. We shouldn't be like redoing the whole thing, right? Because we have one render effect in our whole app other than the one on the count. So we have two. We have the one on the count, and then we have this one. So which means that essentially every time we do any top level action like this toggle, it's calling both. It's calling both, right? Yeah, there's something not quite right with my logic here though, for it to not be doing the hiding, because what's happening here is we're returning a function and we're just going through. So what does this render effect depend on? It depends on show of both of them. And the show of one of them calls children, which creates the show of the other one. Now, these are nested in functions, so they're in separate contexts, but this unwraps them all at the same context, and it just recreates everything. Right? The fact that the toggle doesn't matter is annoying, but it doesn't actually stop from what I was trying to demonstrate, which unfortunately only works when the console's open, which is that toggle gets called twice, I believe, every time I call this. That's twice. No matter which one I hit, it's going to get called twice. And that's not good. It suggests that these can't be in the same effect. Now, when I first created Solid, I didn't actually know how to solve this problem. So I did something kind of interesting. I decided that we would recursively create render effects. So basically up here where we're doing the main render, I always tell people that solid's like effects and effects and effects, right? I would actually like basically wrap this in a create effect. Oh, I did it again. While loops are very dangerous. I can't open elements, unfortunately. I can't right click. I can't open the thing. The only thing I can do, it's almost okay because I'm almost done this section. I'm going to talk to this a moment before I lose all my lovely work. Yeah, I'm just going to talk to this instead of rewriting the code again. We'll jump to the next topic after this. What I effectively what I would do is whenever I was calling an insert function, when it came across the function, it would go in and create an effect inside an effect. Now, the challenge with creating an effect inside an effect is you need both pieces. You need the node that you're going to insert into, and like and the code, like you have the code, but you also need to know where you're inserting into. Now, if it's like this, where it's a single chain, it's going to they didn't let me get away with this. It's going to essentially reference that same element. So even if the lowest level effect updates, it's just going to write that its contents into the element. If something higher updates, it's going to create another. It will recreate the effects below it, and then insert into it. But what it means is that you basically have this ability to separate, like on one side the control flows are sending functions up, and on the other side yeah, I'm gonna have to refresh this. Yeah, at least we have this piece of code so I can talk to it. Thank you, Dev. I'm just gonna pop this code in so we can look at it. I don't know if I'm gonna spend the time getting it all going again. It's funny. It's like it will format certain things, but it won't format other things. As long as I get it back to being legal JavaScript, I think the formatting will work. It's weird that it's not like actually missing a semicolon. Thank you. Oh, it's that one. It's the one before the return statement. No? Was that one before the setter? Or that one? No, the problem is people say how semicolons are optional. They aren't when you have a function next to. It's fine. I can just separate it out. Yeah, it's fine. What I mostly wanted to talk to was the code in here without. At least format. Okay, there we go. Unexpected token period. Okay. What I wanted to talk to was this in here, right? This part of the loop. Thanks, Dev. Is that like if it's if it's a single element, this is pretty easy to just like replace the children, you know. It's actually, this is function, isn't it? But how did you get so close to the actual code? This is actually funny because it's actually it's almost right. Funny. Create render effect. Only part it's missing is the actual call to render, I think. Anyway, that's a syntactically correct, it'll crash again. I was getting to the end of the point. My point here is, which is mostly that like, while this wrapping seems kind of fine, it can be incredibly, you know, wrapping each one of these in a create effect, it can kind of like solve this problem to a certain degree. It gets a little bit more complicated when you have fragments, because now you're replacing parts of your UI, not just replacing a single value in the index. And when I created Solid initially, I actually used like fake special fragment type nodes. Actually, it wasn't just because there's no. The problem with document fragments is they lose their children. So I like did this trick where I'd keep references, and each nested effect could like operate on the specific portion of it. It was expensive and it was complicated. So I'm actually kind of not going to go into too much detail of what that looked like because I got rid of it. The second problem is context. Guess trying to make me crash again. The second problem is context. And because if you are passing functions out of the thing, they're no longer executing underneath the context provider. You like, can you picture like you create, instead of this being a toggle, this is a context provider, and you're literally going like create context, and then the functions are literally passing out and getting evaluated by something above it, like some effect that's higher up. So like I started here because I assumed, and I think most people who make reactive libraries assume, that people can really just pass functions anywhere. If you guys remember old Solid, I mean, it still works in Solid, but if you delete this, it still works because you can just pass a function in, and because of this recursive logic on insert, it will resolve it. We don't do that for attributes, but generally for inserts, you could do that. But if we do this now, you see this like type error because I actually made this illegal even though it works in Solid 1.7. And the reason for this, besides it being really confusing when you go from here and then suddenly it goes this times 2 and this doesn't work and you actually have to change it now to here. This is an old knockout problem. Beyond that being really annoying to deal with, the consistency of being able to pass, like say always pass as a value, is a good mental model. It was that people were taking components, fragments, whatever, and just passing random functions in because they realized they could just execute them by passing them in. Like you could have a component that doesn't take a function and people just like, for children, people just pass a function in, like suspense. And what would happen is it would get passed through the component because they go, props.children and get a function and then pass it like into something that would then pass it through. Like this problem is something that I call onioning, where essentially on the reactive graph side, you're always putting functions and functions and functions. And then on the other side, you're always unwrapping the functions. So it's this two-sided thing. And this is fundamental to fine-grained. And my initial approach was, because I assumed that people could pass functions wherever the hell they wanted, was that I needed to guard really heavily on effects and make them as granular as possible. However, that means, that doesn't solve the context problem. So the solution to the context problem is actually not that difficult. You basically can, specifically in things like context providers, also do this thing. That's why like the children helper in Solid, if you guys are familiar with it, basically goes through and calls all the functions through. But we have to be careful of this double toggle problem that I showed before, where it calls, if you blend them all together, then you're going to call, what? If you blend them all together, you're going to put them all together in here. If you call function, your nested control flows under your context provider would also completely wipe out like React does. So how do you solve this problem? The answer is actually relatively simple. You wrap all the functions you return with create memo. Now, as I said, I would have liked to probably show this a bit better, but if you wrap the functions with create memo at the control flow points, it means that even if you are unwrapping the functions, they'll return the same previous value unless they've changed. Smells like React. But it's React on each individual thing. Basically, I'm getting there. There is a difference from React, which we'll get to as well. But you start putting create memo on the control flow functions you return. This way that they isolate. So around the time I released Solid 1.0, I had a children helper that literally went through and wrapped every function you returned in create memo. And then I had an insert function that basically wrapped everything that it got coming back out the other side in render effects. It worked, but try debugging that code. It's like playing ping pong, because you're wrapping everything on one side and then you're like wrapping it again on the other side. And as I told you, new area, no one had been working on this stuff. Solid was still at the top of benchmarks with this, because this only impacted areas where you weren't directly going into a div, because a div is where it stops. Once you hit an element, you just render the thing in. It's when you start putting control flows, nesting of control flows. When you start creating maybe fragments. As I said, originally Solid was using effects for render effects for fragments, but then I was like, oh, this is really complicated for bookkeeping. So we started turning them into arrays with memos for expressions, right? Which is where I was getting, where someone earlier in the stream asked if like it's better to return a function or return a fragment with just one expression. Well, it just makes it into a memo. So fragments would memoize the reactive expressions, not components, because they're not necessarily going to return the, if they return a function, they should memorize it themselves. But, I'll just open another playground just so we can see this really, really simply. Just going to make a fragment down here, const f equals, show you the rules for fragments. D create comp, let's just do comp. Let's do S signal function. Okay, here we go. So what we got here is 3 different types of expressions for this F here, okay? If we go and look at F, what you're gonna see is an array with D directly, because it's just a simple value, create component directly, because it's a component, and then S is a memo of S, or if it's S times 2, expanded out, it's a memo that wraps S. So, in a sense, getting back to what I was talking about here, there's a lot of wrappers, but only in the case, like each DOM node is a reset. Each nested DOM node is a reset. That's why when I did the example earlier and I turned this into a div, that was my little cheekiness of doing a reset, because technically it's just a node element. It handles its own state in isolation, right? So this is actually one of the biggest difference in a sense, because what you can view is fragments and control flow in between your element and basically fragments and control flow in between like where your state changes and your elements act like mini auto-memoized VDOMs. Every time you hit a native element, it stops and it starts over again, which is different than React, which is a whole VDOM. So where I'm going. I realized in Solid that this was like a crazy amount of wrapping. Like people didn't hit this problem very much because your control flows are generally not that nested, and your fragments do hit elements, and it's generally okay until you start getting into that overwrapping on both sides loop, like with context providers. And then I realized something. No, see, inside a div, you don't know. We just do multiple. Let's take a look. We do multiple effects, or we do one effect that writes to group. We have a mechanism for grouping effects. So yeah, mix, but like. Yeah, I mean, let's look at some compiled output. Look at the difference between this and this, right? Here it is. What we actually do is, in this case, there's actually, because we separate our inserts and we don't group them, we actually create 3 effects. One for, this is an interesting one. Why is this? Okay, no, this insert D is not a function. So this one will just do the insert logic normally. This one will do the insert logic normally as well. This one will pass a function to insert, which will create effect on the inside. So but essentially we separate into 3 different insert calls, and then I decided that inserts shouldn't group together because generally speaking, you don't need to reevaluate them together usually. Attributes don't carry as much expense, so it's kind of like a heuristic thing. But what I was trying to get at is, I realized though that there's a simple pattern that avoided us from having to wrap everything all the time on both sides. The first thing that I realized was that if we memoize the things that matter, like those fragments or control flow places where logic can split and run independently, a children control flow doesn't need to wrap each one because all the key memo places are taken care of. The only thing you have to separate is the first one. What I mean by that is, if you pass a provider and you pass props.children, you don't want props.children to get wrapped up with the children it returns. You want the create to happen and then separately unwrap all the things it returns, because you never want the update of the things it returns to cause it to recreate them again. It creates a loop. It blows everything out. So as long as you separate the very first one, instead of, like, basically, if you go, if it's a function, memoize that, then make a separate one where you just go infinitely chugging through these while it's a function, you won't cause it to blow itself up. So as long as I prevented the end user from just passing random functions everywhere, like I talked about in Solid 1.7, by making it illegal, like, it's not going to matter in a div, but if people start doing that in components and context, doing that, as long as we prevent that, it's a simple thing to do. It meant that we didn't need to memo wrap everything. Essentially, we can just trust the compiler to put the memos in the right place. And I realized much later, probably Solid 1.7 time period or 8, that we didn't need to wrap all the effects. We only needed to separate again off the one level, and then we could basically just fire through these because they're already memoized. Okay, why am I talking about this? Because if you thought that fine-grained rendering was like a VDOM already, I kind of came to an interesting realization while working on Solid 2.0, which is that do you know how many functions you're passing around? Yeah. I mean, what I realized in Solid 2.0 was that some of you might have seen that I've been working on stuff where my create render effect is split as an API, right? We're all accustomed to, writing effects like this these days. You just go make an effect, read some stuff, do some side effect. But for async reasons, I've been looking a lot at splitting them so that there's the tracking side, where you go, oh, I listened to count. And then there's the side where you're like, now I actually insert it in the element, whatever this value is you got from count. Oh, I love when it doesn't do what you expect, right? Something like this. In order to split this up, it means that, well, you have to make a couple decisions, right? Where, if you have nested components, do they get created on the effect side or do they get created on the pure side? If you have nested reactivity, if you're building up a whole graph, right? Before, it was very like basically we just had this kind of hodgepodge together where we're just calling functions and that return functions, and then eventually they kind of come out the other side backwards and we resolve them through. If you're going to split them, you have to decide where you do this, right? And what I realized is that this resolution is always on this side. In a sense, you create the DOM elements, like all these, buttons and all these pieces in the pure side, which probably seems kind of weird, but you insert them or attach them to their parent in the effect side. What this means is this side being pure is essentially a memo, and it's similarly there, which got me to realize, I know this is kind of crazy, it took me so long to get here, is that even though like there can be, let me do this for emphasis. Even though there can be other effects even though there can be like other effects in the pure side and other effects, and you can nest these separate starting points, these mini virtual DOMs, as I was calling them, inside each other like this. The actual place where the world sees the impact doesn't happen until you run the outside. And this means, because they're returning these values essentially, like this one returns count here and this one returns count here, that if you're already wrapping at all the right places, like with the control flows and the fragments, the unwrapping happens over here, and it only needs to be one layer deep, like we talked about before. Essentially, we don't need to nest additional create effects to do the rendering like I was doing before. When I was like, this effect is like nesting a div inside a component. The looking at the like return type of the count or thing is not something that we have to handle recursively. There's basically no onioning, because you already have all the memos coming in, and this side only needs to trace through the memos, which means that the act of resolving the inserting of the DOM stuff, like I was showing, like that insert expression, is the exact same logic you need to resolve children, because it's all the same thing. It's just resolving stuff on the pure side. There's no additional effects involved, so it collapses the whole system. And I want to show you what that looks like, actually. So I'm going to go into DOM expressions, and I'm going to show you. Let me show you something, because if we look in something like Solid today, and we go into the client.js, and we look for our favorite insert expression thing, there's a bunch of extra hydrating logic, but what you're going to see is, ignoring the hydration logic, it goes, while type of current equals function, unwrap it, like we were just talking about. And then it goes, okay, if they're equal, early return it. If it's a string, do some text operations. You can ignore the multi stuff right now. If it's a Boolean, basically just skip it, clean it out if it had stuff, like, because you skip nulls and Booleans in JSX. Oh yeah, sorry, this is current. This is not what you think it is. Current is the previous value. This is the weird thing I had to do because of the nesting of functions, What actually happens in solid, sorry, is if it's a function, it creates the effect, and then sorry, it jumped on me here. There it is. It creates the effect, and then what? Actually, that was a weird jump. Sorry, that was not insert expression. Like jump to a different version of the code. Okay, sorry. It top level creates effect, and then it does the while that I was talking about. Sorry, I told you it had to create one level deeper of effect, and then it does the recursively calls itself and does the insert again. But this stuff's all tangled together. If it's an array, then it normalizes the array information coming in, and then it again does an insert expression. Basically, there's all this kind of tangled logic that handles both resolving and normalizing of the values and doing the side effectful part of actually rendering in this function. This is the core of DOM expressions, and it's probably the most important function in the whole library, is this insert an expression. The reason I wanted to show this is if we were to change this around to split, like I was talking about, insert expression. What actually, sorry, I have to go to insert first. The thing that calls insert expression, my bad. Insert expression gets called by a function called insert, which checks if it's a function and runs it normally, or otherwise it checks if it's an effect and wraps it. In the old version, as I said, it just called insert expression and put it in an effect. In this version, the separation of the render, passes it to the normalize first, so completely normalizes it before it passes it to the insert. And the insert now, which is what I was trying to show you, it only does the side effects. It's like, if it's a string, do the stuff. If it's this, clean it up. You see there's way less code here. I can fit it on one screen now. If it's a node, replace it. If it's an array, if the previous one was empty, clean it. Otherwise, do this. This is basically reconcile and do all the diffing. So normalization handles all the weird, like there's no normalize array call here. There's way less like if it's this, do this kind of logic. And the normalize code that's in that first half looks like this. It calls this one helper called flatten, and then it does a little bit of normalization of changing text nodes to strings to text nodes, which will probably go away in the future. But the reason I want to show flatten is because if I go to solid.js here, which is, sorry, where's the GitHub? Is that Reddit? That's GitHub. And I go to the next branch here. Packages, solid. And I go to the children helper, the thing that resolves children. It just goes create memo flatten. It's the exact same logic of resolving the all the arrays and functions and arrays and all that kind of stuff between rendering into the DOM or resolving children's for context, right? So what does that logic look like? Signals, solid.js signals. I know this is very specific to solid, but right now, but this was a big revelation to me in terms of rendering, which is why I wanted to talk about this, is because core utilities, utils. Flatten is this function. There's some stuff involved, but it goes, if type of children equals function and not children length, this is checking for functions with arguments for some reason, something I've always done. I have some like other options here, but essentially it does a while loop where it unwraps it. And then if it's not an array, it just returns the value. If it is an array, it nested goes in and it goes through each element of the array. Again, function unwraps it. If it is an array, calls itself again, you know, and recursively goes through and handles functions array. The only thing that's a little bit interesting here that I'll mention is that each element of the array is handled in a separate try catch. This is just a small note, not too important, but it's so that if any part of it errors specifically because async through, it still processes the next thing in the array, like the next item. This is the React 19 problem. You know how in React 19, if they throw on async, originally, I think they fixed this. It would like basically if you had siblings doing async, they would waterfall. It's because if you throw a promise while iterating over one of the pieces of async, it doesn't get to the next item. So this is to protect against it. It's funny, in Solid I never used to worry about it because we didn't throw, but in Solid 2.0 working on this, I realized I had to throw. And this, again, the same throw interruption impacts DOM rendering the same way as it impacts resolving, you know, children. So this way the siblings still pass through. Yes, this is what I meant. I was helping dev with a demo and I hit this. My point is, my point is the signals library now has the majority of the code for rendering, so to speak. It's not rendering, it's flat. It's flattened, essentially. It's like flat, you know, it's like map.flat. The reactive equivalent to map.flat is basically, if you separate the effects full part of rendering from the pure part, you can reduce the problem into these flat operations as long as each section is separately memoized. So, yes, what we've created here, ironically, is sort of a VDOM, right? Except it's only as deep as the decision points. You don't recreate any artifacts like virtual nodes. It's just the holes, right? Because your skeleton are DOM elements, that original pinpoint update thing we looked at. But then the logic that helps you do control flow within the holes is essentially separately reactively memoized. The difference between reactive memoize and top-down memorization is you can start at any point. If you have a fragment with 200 children inside a fragment, each with 200 children, if you update the one memo, the second one down in one of the rows, a reactive signal library will start from there rather than go all the way to the top, check, diff all the 200 and each of their 200. You know what I mean? Like it doesn't have to mark it dirty all the way down the chain, and it doesn't have to check dirty all the way down the chain. But essentially, it's not actually that different when you consider that. I was talking about those streams going through your app when they update. When I split the render effects, like I was talking about here, when I split the front half from the back half, where is this? Where is it? I thought I put it in one of these. When I split the render effects like this, you actually see that split. The front half is the essentially the virtual DOM, and this is the actual effect. The deeper this piece is, the more dynamic work is being done, even if it's slightly more granular. But the difference is, as you construct your graph, every element, is a chance to restart. It's a chance to act in complete isolation. Anyway, I'm hoping some of this makes sense. Did we answer the question though that we set out to answer here? This is this is basically the the core mechanism though, right? If you have the how did I frame it in the video description? Let me see if I can go on YouTube and see what I actually wrote for this stream. Give me 2 seconds. Sure. Okay. What did I ask? What makes solid Salt 5 different than Preact, Qwik, or React with Jotai? Okay. So the the difference with there's basically 3 stages of this, right? There's React, which when state changes, everything below needs to rerun, right? Both if you update the smallest thing or you replace something or do some kind of control flow. Like if you map over some data, like an array, and a checkbox in a single, like a done on a single to-do changes, React has to mark the whole to-dos list as dirty, rerun that component, even if it's memoized and it doesn't like touch the other piece, it still goes, okay, well, this array did change. So it reruns the whole array. And then it goes, okay, I realize that this item in the array has changed, recreate that item, and goes, okay, I realize this particular field has changed, recreate that field. It can skip the other work, but it basically does everything. Even with Jotai can be like, hey, we know that, we have this, say, state that's higher up. We don't need to re-render all the components in between. Only this component depends on that state. Jotai saves you that problem, but it doesn't change the fact that at whatever point you start rendering the data from Jotai where you use it, that becomes like the use state localized. Jotai just lets you get rid of the code in between where it's defined in the tree and where it updates, and where it's used. Okay. Yeah, the infinite loops did not let me help because I don't have a working example to show you, and rebuilding it over and over again is kind of difficult. See, with the flattened helper, it's a way easier for us to build a renderer now because we can literally just like wherever wherever this code is here, we can just basically be like, instead of doing this, we can just be like flatten this in and replace child is essentially what the logic becomes. Because it's a generic routine for saying if it's an array, if it's a function, don't worry, we'll just reduce it down for you. I'm like debating whether I want to do that, but given time, I don't know. But what I'm getting at is when I'm talking about the difference between these solutions in React, wherever this statement happens, wherever you go const, s use state, that's where the rendering starts from when you wherever you call that set. With Jotai, you can essentially pull this out, so to speak, but then like wherever you bring it back in, that's the component that will render. Wherever you put set doesn't need to, like, quite often we hoist stuff because we need set. If you bring it higher up in the tree so that other things farther away call set, then unfortunately everything below it changes. With Jotai, you can actually separate the read from the set essentially. but you're still rendering components completely from that point, no matter how much or how little you do. Qwik and Preact, in a sense, with their signals implementations, and we make the signal, let you do this Jotai thing. And in addition, even if it's in here, if there's a specific place where you're like div, s dot value, I think what they do, like where you put it in a specific node, they can go, okay, we don't have to rerun this component. We literally just have to update this. But if this is happening, so to speak, like your control flow, like let's pretend let's actually do let's do something more fun. S dot value dot map. Essentially, you're not getting fine-grained updates anymore. You're returning right into VDOM update territory, right? Fine-grained rendering means that you only care about the holes. You're never recreating the DOM elements that you don't need to. Essentially, it's all guarded with separate events. You don't have to update the data from the value to know that. You can make it granular. Obviously, things like proxies make this easier. You find that's why Vue, Solid, Svelte all have proxies to make it easier to trigger. But it's more so that each of these pieces aren't defined so much by the component that they're in, but always by the expression that they're in. Yes, you should be able to build some amount of control flow aspect of it, which would definitely, because yeah, it's the memoized control flow. The interesting part of that is like what the VDOM is doing at that point, because there's still one extra step of creating the VDOM nodes. It's basically like like you can use signal style optimization to create VDOM nodes that then get diffed. You know what I mean? Like it's one extra step. So I would not be surprised to see it get to not Svelte 5 levels, but to get to Svelte 3 levels, as you were saying. So yeah, that makes sense. So it's interesting because does any of this actually matter to you from a practical standpoint? It just means that we've seen a reduction of almost like a streamlining of code in the same way that I showed the move to Solid 2.0. Instead of introducing new concepts, these things are all the same concept. I think that's one of the most interesting things that I've been kind of realizing as I've been working through these kind of problems, is that like like if suspense in a fine-grained rendered system is literally a combination of computations in a certain configuration. It's like we're playing with Legos. Instead of creating a bunch of like new concepts in code, like there's a bit I needed to make a special type of computation, that has a little bit of special logic, and I've introduced this idea of like schedulers in Solid in terms of time, but once I have those primitives, like the idea of a scheduler, you can model like incredibly complicated things by just putting the pieces together. Now, on one hand, this might sound like I'm making the RxJS argument, where it's like, it's so much easier to do all this retry logic because you have these pieces, but then you're like, well, do you even need this at all anyways? You could just like write this, the thing more directly. Why do you have to jump through these hoops? Well, for it to work reactively, you need to work within the language of it. So you have to jump through the hoops. But it's interesting because it makes the concepts not special. Yeah. Yeah, what's a live computation? Oh, nothing. That was just a term that I used for I wanted to make an eager computation that yeah, honestly, this is just telling it to participate in um let me look here. Yeah, too deep for the stream, I think. It's mostly just because I wanted it to participate in suspense itself. It's in case someone does something async top level. Anyway, it's not important. Okay, okay. I'm here to answer any more questions on the rendering. I know I kind of got off a little bit here, but I'm hoping like you can start seeing fundamentally that at its core, fine-grained rendering is actually more of the same in terms of just component or signals composition. You're just like writing functions that return memos that get read by other functions that return memos, and they just kind of at a certain point there's like one function that resolves it all down into like a flattened version, and then you take the flattened version and you look at what you had before, and either you insert it or you diff it if it's maybe, you know, some elements, and then you're on your way. There isn't much more to it. Yeah, I don't know. Other than that, I wanted to talk about async, but I don't know if anyone cares to talk about async. I wanted to actually show something kind of cool and ask a question. The only problem is I didn't download it, which was silly of me not to do before stream. I was just so busy working on setting up that tier list that I didn't actually download the async example I wanted to show. Well, it's your example, Dev. Do you have an updated version of that anywhere that I can pull down? I wanted to look at your demo for a minute. Yeah, I just don't remember it. Can you send it to me on Discord? Yeah, if you can send it to me on Discord, that would be great. Thanks, Dev. Okay, nice. And I see you've actually copied the versions in. Okay, cool. Let me just grab that. All right. Not right now. All right. Let's get this. So yeah, let's talk async for a bit, unless people have more questions about reactive rendering. I actually tried to write an article about reactive rendering. I'll share it right now. I think it's linked to one of my older articles, which was God, I have so many Dev2 articles at this point. Which was it? Signals. No, building reactivity build. I can never remember the name of the stupid article. No, it's older than that, maybe. Yeah. The bottom of this article, I link a much older article. Reactivity to rendering. Oh, in-depth took it down. Okay, SolidJS, reactivity to rendering. Reactivity to rendering. Angular love. Interesting. I've tried to cover this article in the stream before. I don't know if I had much more success. I was trying to show how to write the insert expression um, um, logic, and it's funny because it's so much easier with flatten, because with flatten the insert logic, if you don't care about diffing, it's literally replace child. You can just replace insert with replace child and just call flatten. Anyways, I'm going to share this on the stream just in case. All right. Let's do this. Okay. VS Code. File, open. Development, examples. Okay. Let's go full screen here. I trust you, hopefully, Dev. Okay. So this is a simple example, but I want to talk about it because it poses an interesting question. Oh, I love this example. I love how you've written it. Okay, this is beautiful. Okay. This example is probably the first compiled Solid 2.0 code you've seen on stream. I do a lot of hand stuff, but this is actually basically this all the Solid 2.0 stuff, but working with proper JSX, suspense, and all this stuff. So, but I need your help, which is why I want to talk about this, because I want to talk about expectations and about how these things should work. And okay, so let's build this first in case I can't remember what the build command is. There a build command? What are we doing here? Dev, okay. Dev. Maybe I need to install it first. That's actually npm. What am I doing? No, whatever. But the weirdest thing is I'm seeing Babel preset solid 0.19. I guess it's still compiled. Yeah, that's interesting. Okay. Okay, we have dev, and then I'm gonna, I think, just npx serve the current folder is how we do this. Yeah, okay. Oh, it's not, I thought I was already cloned. Okay, okay, fine. I'll clone solid signals over as well. Hopefully I have that on here. It's possible that I don't. Yeah, see, this is my new Sentry computer. You can tell I don't do my work on this computer. Which is why this, yeah, fine. Let's go get, I mean, we're right here. It's fine. Make another node here where I'm gonna go. Get clone this one. Just open in another window. Yeah, signals have been getting a lot of updates actually. So let's make a file, new window, file, open, development, signals. Okay. I'm trying to remember, do I just put the dist folder in, or do I copy? Let's look at roll up and see what it's doing. The alias plugin. I'm looking at the wrong, maybe I'm looking at the wrong thing. Where is it? Look at the README. Oh yeah, I'm like in the wrong thing. Okay. Yeah, because all I was doing, I think, was doing this. I think I was literally just pasting it in like this. See if this will give me what I want. Funny that the zooms are different on these. What does it say? Oh, interesting. It's because there's no. Okay, I see. You actually. Okay, it's fine. This is. I see why. It's because XJSX is. There's no disk folder in here. No? No. The funniest thing is it's. Oh right, no, but where's dist? There's lib. Dist is not here. That's what's weird. Yeah, I mean, put the wrong command in. There we go. All right, that's what I thought. CD okay. Dev. Oh right, because the latest solid. Yeah, okay. Okay, it's okay. This is fun. This is what happens when you build demos on the bleeding edge. The latest. I need to actually. It'll be easier if I add this into file, open. We're gonna check out this version and build it. I changed the error handling, which is why this doesn't work. All right, let's try this again. See. All right, it's fine. I need to give you a new version of XJSX. Dev. It's fine. It's good now. Doesn't matter. Oh, okay. Beautiful. Okay. So we have a simple demo. Okay. Let's talk this. So we have a loader for the whole app, then it comes in, and then we have a loading for this message, and then every time we click, it loads a separate phrase. Okay. Right. So we just got a couple suspense boundaries, okay? And the way we author this is like this, okay? So fairly straightforward. The app has a couple fake fetch calls, one for getting the hello and one for getting praise. these would be API endpoints or server functions or something for the case of this. And then this is the app getting rendered. And then the main component, console logs, I guess it sets up a signal, which is for the counter. I don't know why this is wrapped in. It shouldn't need to be wrapped in a function. That's odd. Anyway, someone probably playing with something. And then just for fun, yeah, okay. And then it's got one async calling the one thing based on the count, and another async calling the get hello, and then it's got an effect that listens. This is that split effect thing I'm talking about, listening to the async phrase. And then here we go. Suspense around this, where the hello is, and the button, and then a separate suspense for that separate loader around the message, where the message text gets displayed. Now, there's a couple things I want to talk about in this demo. Because I need to kind of both show what it does, but also get some feedback on some aspects of things that seem expected or not expected. The first thing that you're going to notice in this demo is that we're loading async up here, and yet the suspense is down here, and there's no problem. And that's because essentially it's not until where it's read that it matters. It doesn't matter the order here, right? We're not awaiting or throwing or something. There's no waterfall by putting two fetches next to each other. And essentially, these are just independent, and they only go as far as they need to. Like if there was no hello here, this isn't being read anywhere, then our app won't need to suspend, when we load it now. There's no hello, so I got rid of that. But only this part needs to suspend, right? You can start clicking this. I mean, you could do it before, but my point is the outer part of the app doesn't need to suspend. Obviously, there's no hello. If I wanted to make the UI of this example, sorry, I'm going to close this because I don't need any more. Nicer, I would, put an H1 here and be like, hello. Now it looks nicer again. But the key point is that the whole outer shell of the app only suspends because it listens to that hello, right? And similarly, if the phrase wasn't a phrase and was just the count, then nothing in our app really suspends. This is now just a glorified counter, right? So as you can see, it doesn't matter if it fetches. It matters if it's read and where it's read. Although this brings us to the first most interesting question here. This effect isn't suspending the components, but it is console logging the phrase when it comes back. So like when I load the page, you're going to see this before this shows up because the effect needs to wait for the data to come in. When I click this will be 1 and then it'll show. And if I go like this a few times, you'll see it trying to fetch and then the final one will come through, right? Because of the way the create async does its cancellation. But what I'm getting at is that like this updates immediately and this takes time. So the effect isn't participating in the suspense. Only render effects do. The normal effect doesn't. And I don't know if that's a good thing or a bad thing, honestly. This is something that I've been trying to figure out when talking to people. Like when I first made the demo, I actually had effects participate. So this would cause the whole outer component, when the suspense was above it, to suspend. And Dev was like, why is it suspending? That's weird, right? If I didn't have this console, this create effect, it wouldn't suspend. And he's like, he asked me straight up, he's like, do I care you know, like, should this cause things to suspend? Sure, this isn't ready right away, but does this mean that you shouldn't like show or render the UI? I don't know. This is an interesting question to me because on one hand, you could say that like to show things consistently, you should suspend, but on the other hand, if you assume side effects outside of the system, you don't really care how long. Like, it's not your responsibility to keep things outside of the system in sync. You were dead with this one. Yeah, I don't know what that means, honestly. I don't think there is much boilerplate. If this is important to you, check out solid labels. There are packages that do this, but if you watch Northern Stream, I cannot, I actually, I don't really get what this even, like, what the boilerplate is. There should be a way to opt in out of different behaviors. Well, I mean, technically, I mean, that's always the worst answer, right? Technically, there is, right? Like, depending on what you want to do, right? Render. The question is, like, do you view rendering being part of the framework synchronization responsibility not to? Because you can understand this effect here, which is a way of observing the data fetching, would cause the suspense above this, like, if there's a suspense wrapping the whole app to trigger, instead of being down here where the other ones are actually being accessed. Yes, this feels reasonable. It's funny because Dominic from Svelte actually showed me a really cool async demo around the same time I was working on this, where he figured out a way of not splitting effects to get what he's going for, and but the effects were still blocking like this, and it was because he was registering the create async with the component, not where the read was. And because of that, you know, he's like, we don't need to split the node of dependencies because it taps into the component. And I was like thinking, I'm like, well, I don't actually need to split normal effects technically, if they don't participate the way this doesn't participate. We could just not split normal effects here. But the problem of not splitting normal effects with throwing is, if someone doesn't read first and they do something partially side effectful, then they read and it throws, they might do that partially side effectful thing multiple times. The splitting is actually kind of like a protection for the user themselves in a throwing environment, right? I mean, to be fair, if you were suspending the whole component, this only becomes an issue. Yeah, because basically, if it's not based on the depths, then it doesn't matter because you're not going to run the effect anyways, so to speak, until the component's done. So like, if this component was, if this was suspending for a different reason, it would still get deferred. You're not going to run an effect on something that's off screen. I'm just saying it shouldn't be the one that contributes to it being off screen, right? Like, if you know, this was in a component that was suspended, we're not going to run an effect while it's like suspended off. But if this is the last effect that's waiting or async to come in and it's not causing the component to suspend, do we have to wait for it, is essentially the question. Yeah, essentially, yeah. Oh, you mean, that? I mean, okay, yeah. Then check out Solid Labels. Solid Labels is a library released 5 years ago to do that. It never really caught on, though. To be fair, I don't think most people care. The biggest thing is that, like, the second you have to move reactivity out of a file, you need wrappers again. So like but it basically creates a compiler that has to process more to basically not change anything, except for like the immediate ergonomics of the thing in front of you. But it doesn't. I actually talk about this a bit earlier in the stream. It's probably hard to dig back there. Maybe there'll be a marker later when we get timestamps. But my opinion is this kind of optimization is kind of pointless. Because it's not really an optimization. Okay, what do we got? Greg and Dev are talking. If it doesn't actually read from async, it should wait for the parent. The way that I'm phrasing this is, yeah, it's basically, it affects participating in suspense. They just aren't responsible for holding it. Is my thinking. So there is a suspense in the parent component of Fraser, and the question is whether create effect inside Fraser component should trigger suspense. Yeah, that's basically the question here, and we're kind of. I originally thought the answer is yes, but I'm kind of leaning towards no now. Yeah. I don't think. Oh, yeah. Maybe not. I mean, to me, it's not even liking. It's just like, that is essentially what it has to be. You can pretend it's not that, but like it is what it is. It's kind of like futile. I guess it is me liking. I'm just saying, like, trying to mask that part is kind of like a hopeless endeavor. Yeah. I mean, sure. I need to put another suspense boundary in here. Let's do it. Suspense. Fallback. The universe. All right. So right now, there's nothing. But if I change this to a render effect, perceptually something that affects rendering, now when we load it, we get the universe, and then it comes in. And because every time we update the phrase, it triggers the effect, the universe just keeps on coming. Right? That's the jarring moment. Right? Yeah. That's the jarring moment when you just put an effect to observe something near where it's fetched, and you're just like, what? Why did the whole app on thing? But the thing is, you have to understand, in React, this is what happens, right? Like, if this was React, I mean, Dev did a talk on this, but think about, if you didn't want that to happen, you would have to pull the out another component, and then put the put the effect or whatever underneath where you want it to be, like all the way down here actually in the message component, if you didn't actually want it to update. Otherwise, like if you just wanted to trigger this suspense fallback, you probably would just not read it that way, and you would use like was that like deferred value or whatever, like intentionally cause tearing or whatever. Like there's ways to do stuff, or I mean, it's the real easy way to do it is just at the point of the promise go then console log instead of, you know what I mean? Like there's other ways to do it. So like, let's go back to create effect here. So, okay. People seem generally on board. I'm sure there's going to be some kind of edge case, but this is sort of the thinking. Now, there is no universe. There's only us. Now, making hello read is not a big deal. We'll add that back in to get our suspense loading. Okay. Now, because hello takes a little time to come in, that, and then this is, we still have the same behavior where it delays where it comes in. Okay. Now, what's interesting to me, though, most interesting to me about this example is picture that you wrote this message component like a long time ago. It takes props.text, right? And now you want to make it async. Well, the answer in Solid, as you saw, was just, it's a signal to signal. So now we're just going to change this one to phrase. And now without changing the message component at all, we have it reading from async data and the suspense boundary. Basically, like the pattern is you go, oh, you realize you're like, hey, I want to add something async at the point that we're some point above where it's read. I mean, you could put the suspense inside if you really want to. You just go, okay, this is where the placeholder is, and I want to catch all the suspense below. But what's interesting is like the end components, like maybe not your like button component, but like the next level up in the organism might not need to change at all if you just change it to an async signal, right? We don't have TypeScript going here, but technically phrase here is not any. Phrase is actually string. It can't be undefined as far as the program is concerned. So there, you notice here that like if you use Solid, we'd have classically we'd have like a bunch of show components in here. Because we're using the throw based thing, we don't need to. This is always defined or it throws. So technically speaking, there's no undefined. And we didn't need to change the component. And it's kind of interesting, right? Because like when you look at stuff like how you would solve this in React, this is the right pattern. You have the suspense on the outside, the command on the inside. But if you want the data to be in here to only trigger the suspense, you have to call the use in here. Now you don't want to fetch in here because you see the problem. You understand the problem of fetching in here. First of all, you have to actually pull this down, and now you can't have it in this effect up here. But the other problem is it waterfalls because like this component reads some data, throws, and then it gets down here, and then it fetches and it throws, which is kind of awkward. But how else do you get the async here? If you want to fetch it up here and you want to get the async down here, you either put use here and block here, but that's above the suspense. So you could make another component and put the use here, or you change this component to accept a promise. So you have the fetch here, have the promise, pass the promise, and then use it in here. But now this component needs to be aware that it's async, and you actually have to change the interface to accept string or promise. I mean, render effects have to cause the suspense because like they're literally like, that's what these are, like it rendering the text. If they didn't cause the suspense, you could end up with hold API. I mean, you could do that, but you want them to. Yes. Sorry. Render effects are equals JSX is the best way to put it. Everything like what I was showing earlier stream, everything that we use to render in Solid is effects. Yeah, it's the exact same thing. That's why they exist. If we didn't render JSX, we wouldn't need render. If we didn't render templating, we wouldn't need render effects. Like that is what they are by definition. They are basically the JSX. Like create render effect exists because you can literally, as I was showing earlier, build the framework yourself. With like from its own primitives. Anyways, what I'm getting at is it's interesting because here we have this ability to not change the API to stringer promise and have it have the same thing. I guess when the interesting question, I guess, is if I take this create async and stick it down inside the message component now, just for fun, put it here. And then props, and let's make this props.count. And then put count here. Do you guys think there's a waterfall? Because like technically speaking, this is an async. It reads here and it throws, triggering the suspense. Will that delay this? Did I miss something here? I thought I got it. Oh yeah, you're right. Change text to count. Thank you. Yeah, good call. Thanks. Well, should this waterfall? Right? We do some async stuff here. We read it here, and this thing down here is fine. It's now just passing the count through, but this is doing async there. It's a child. It's not a sibling. It's a child. We have a component, here that does suspense, that is definitely suspending. Should it wait to call it? Right? Anybody? Dev already knows the answer, unfortunately. I was like trying to see if anyone else would guess what happens here. And the easiest way to confirm this is let's make them both take the same amount of time. So is it going to be showing up one, then 2 seconds later the other one, or are they going to show up at the same time? They show up at the same time. So nesting fetching doesn't waterfall. No? Okay. I have too much fun with this stuff. I think people at this point are just like, Ryan, you just tell us how it behaves. Like, we're going to assume that it already does the thing that doesn't seem possible. Yeah, guess what? We didn't need server components for this. Oh well. It's so funny because when you play with this demo, there's like so many variations you can do where people, like if people come in with React Brain, they're going to be like, this is impossible. And this literally, it's so weird because sometimes when you make stuff, like I think in solid, so I can't be the guinea pig, but because of how much simpler the model is, it's very easy to come up with an example where you kind of go, like the original example that Dev made, or what I just did here with nested, and then you write it this way, and then you in React, you see the waterfall, you go and you fix it in React, and then you come back to solid, and then it just works the way it originally did. I love demos like this. It's just, okay, do you guys want to know how this works? Okay. So the gist of it is it's the same mechanism, and because you were following the rendering stream so far, you should have an idea here. This is an effect, right? This effect catches, essentially. The way that this errors and async work in Solid 2.0 is that memos catch the try, like every reactive context catches the try catch, but then it sets it on itself and says, I'm errored. And if someone else reads it, it'll be like, I'm just going to throw the error. So in a sense, they keep the propagation going, which I'll demo in a minute. But effects are the ultimate, I've caught it. So if you wherever you read the memo doesn't matter. It's what like is holding it where it finally gets down to that effect. It's just like the rendering. Remember that normalization? I showed you that flatten function where for each branch it was checking, because if it got that not ready error, it would essentially let you process all the siblings, but then it would throw it up. Eventually there's an effect that's going to get that error, and it's going to go, okay, I've got the error, but it's on the front half. So it hasn't run its side effect yet. And it goes, okay, now that I know that I have the it's suspended, or I not suspended, but like there's something async here. It uses its ownership context to find the suspense boundary and toggle it the way Solid 1.0 works. The communication between this effect here and the suspense is not throwing, it's context. The throwing lets us be non-null, unlike Solid today, where it was null, but the suspense is still working off context essentially. So it just goes, okay, I'm under you, you should suspend. But you should suspend, that's what that live computation was, essentially, dev, is just because you're showing the fallback doesn't mean we have to destroy what's on the other branch. We just keep it sitting there off screen, essentially. It's live. So we've created a bunch of DOM nodes, and this is a fragment. These are siblings. So the first DOM node, and it actually doesn't even matter that it's a fragment because there's an H1 here. Remember, we hit a div, it stopped. It doesn't go into here yet. So the boundary here, like the memo that, so to speak, the top level one that gets all the stuff, just sees 1, 2, 3, and it sees another suspense boundary, but it basically sees some elements and then another function. When it gets this, but because each one of these is processed in its own try catch, this throws, I mean, it doesn't even matter if, honestly, this would do the same thing. Let me do this, show you it's the same thing. If it was a fragment, the fact that these are separate would matter, but because it's a div, this is its own separate render effect. It captures the asynchronous, and it just tells the suspense to go to fallback. But meanwhile, this is sitting here with a bunch of divs or a bunch of elements. This H1 might have no text in it yet because it errored out, but it has the H1 element. It's already rendered the page, even though it hasn't shown it to you. And then it goes into here because these have nothing to do with each other. And it tries to execute this, and then it goes here and it creates this, and guess what? Another fragment, and then it gets here, and this effect now also is where the throw happens, and it errors and tells its suspense boundary that its fallback is. But because it returns the P in some of the text, the thing, essentially, it's just sitting in off screen of this one. So this one's floating a P tag off somewhere. This one's floating the H1 tag off somewhere. And then when this resolves, it'll just tell these to re-execute the specific phrases, like phrase and hello to re-execute. So when hello finishes, it goes, oh, re-execute this, which will then give it its text. And then it'll attach the DOM nodes you created originally. It doesn't re-render anything. It just takes the DOM nodes you created on that first pass and fills them in the same way as always. Well, if there's no element, that's where the flatten does the work, because essentially suspense itself will catch it then. Like there's no effect that it's going in, so suspense will catch it. It's a boundary, and it will call flatten. And when it calls flatten, do I have this code still open? When it calls flatten, I actually showed you all the code earlier. Core utils calls flatten. The first thing it's going to do is basically go through this array procedure. It's going to get to the flatten array and be like, okay, so for each child, get the child. So I'm in a try catch. if child equals function, yes, it's an expression. Forget about this. Do child unwrap. It's going to throw at this point because it's going to go, not ready. And then it's going to catch it and go, hey, it's not ready. If it's not ready, it throw you. Otherwise, it's just going to set a flag not ready. Then it goes to the next loop and draws its siblings, right? And then when it's done rendering all the siblings, with some holes, where it threw, it's missing the thing that threw. It's not added. It then throws itself, and then essentially you have to remember that all these expressions that it's unwrapping here are separately memoized. So even though this whole function is going to run again, it's going to be reading, as it unwinds the arrays and the functions, it's going to be reading pre-memoized values. Like all the things that were static, the things that were resolved are going to be already resolved again. So it doesn't need to create them again. But it also is non-blocking because each separate element of the array can process itself before it communicates it upwards. Hopefully that makes sense. So whether it's doing our mini VDOM with the flatten utility, or it's just like literally just telling the one effect that, hey, there's no text here yet. That's the easier case to visualize. It doesn't need to re-render, right? This is not only, it's technically blocking async is the funniest thing because of the throwing. It's just fine-grained blocking async that doesn't re-render. It's basically like everything Solid has shown to do before, right? With rendering, we showed that you could not re-render components and do fine-grained updates. This is fine-grained suspense. So current Solid doesn't throw, so it has to null check. This doesn't need the null check, which is nice because as Katie is saying here, switch and show results in waterfalls if I understand correctly. Right, which is why I still like hoisting, why I still suggest hoisting type patterns. But the thing is, when are you calling show? Because if, God, I have to reverse this, I think now that you've seen this example, let's go back to fetching above. Okay, we're fetching above. Okay, as I said, it's already cool that you don't have to change this, to make it async, but now we're fetching above, and let's do something fun like to uppercase. Can you call to uppercase on undefined? I don't think you can. No. You can call uppercase to uppercase on an empty string though, right? Okay, beautiful. Okay, so this serves my purpose. I am basically, if this is null, undefined at any point, this is going to error out, right? But I'm telling you, this will never proceed as undefined. So I can put to uppercase here completely safely. And when my thing loads and I click this, now what didn't happen? Why am I not seeing to uppercase? Oh, I have to save it first. Duh. Okay, let's try this again. See, it's uppercase now, right? It's not like a lot of these advanced, like these cases where like you would put show, like you will use show for layout reasons probably, but maybe those are the places where you'd use suspense. Maybe not, but what's interesting is like, because it can't be null the way this is permissive like this. I mean, it gets really fun because then we can be like upper phrase, right? Like this const upper phrase equals create memo. We already know conceptually that a function is going to defer it to gets called there. But what's cool, unlike solid 1.1, is that memos also see this can be null, right? It can't be null, so this is fine. But they also propagate this, so this should just be this same problem. Create memo is not defined because I did not import it. That's my bad. Create memo. This isn't going to cause the phrase component up here. Like, you know how we were wondering about create effect and create render effect? Create memo is not going to cause this phrase component to suspend, because memos only care about where they're read, right? So this is doing our to upper phrase, right? And even though we're like deriving logic, first of all, this logic is not null ever, which is why this works. But it also, just like any other reactivity rules, propagates it down to the read, so it's only the suspense boundary that gets triggered. Upper phrase is the new double count. Okay. I wonder these Spencer, can you do advanced things in fallbacks, or are they dumb like V1? What happens if you... I mean, I didn't think V1 was dumb. It was by design. Fallbacks get handled by the parent. That was always the thing. It's actually part of the difficulty writing error boundaries and suspense boundaries is that the fallbacks are not part of it. They are part of the parent. You don't want... It wouldn't make sense for the fallback to trigger its own suspense, right? They get handled, as you nest them by the parent. Like, this would be really weird, but like we could probably put this here and then like put and then depending on the difference on the loading times, I don't know if we have, yeah, okay, they're still differed. Hello is 500. I mean, will it? Okay, it won't, but they're fetching in parallel, so you don't see the difference. What I'm saying is I have to make this one long. It's now waiting it's now waiting for the phrase, or it should be waiting for the phrase. That's interesting. Maybe there's a bug here. Why am I? Because... Oh, right. This doesn't work because it has to suspend, because otherwise this will never be in fallback. Okay, I'm done. Fine. That's... yeah, this idea is dumb. It doesn't work. I mean, it works, but I need to like... I'm trying to think of an example where this would... I'd have to add like another async for me to show you what, like, because this has to suspend and then this has to suspend less long. Yeah, I don't feel like making the convoluted scenario, but yes, it should be caught by the parent suspense. Yeah, the fallback isn't rendered. Okay. But I think this kind of shows the three different scenarios, right? You can fetch nested without waterfalls, and you can derive without blocking too high. Like basically, and you can do all of this stuff without changing the API of your components that fall under it. So some people were worried about that, and maybe you're concerned about it, but it's like if you add async into your app, you're the one responsible for putting the suspense boundary in, right? Like, I mean, that's kind of obvious, but if you add fetching, are you the one responsible for changing all the component APIs between where you do the fetch and where you use it to promises, so that the props accept promises? So like I guess the worst case scenario here is that you don't have access, so you can't add the suspense boundary. So then you would put the suspense boundary at the same height as where you would have put the U's in React. The only difference is, and this is more of a performance difference consideration, is while visibly it would look the same as React, when it does an initial pass, it will render all the rest of your app except for the small places where the async is being used, and it won't throw that away and re-render it again ever. It's like it's the render once happens during the initial suspense render. Right. I don't know. I think this is cool stuff. I was talking a bit about this on a podcast not that long ago with was it like .dev or whatever? Not why can I remember? Tracy Lee, her podcasts, and it was a really good interview. Not many people have watched it. I'm actually going to link it here in case people want to see it. I talk all about why I think these models are really powerful. Let's see if I can grab it here. I also talk about single flight mutations. It's so funny because they got me on the stream to talk about single flight mutations in solid start because, you know, that's the thing. But I've been like, by the time something gets to the topic where like everyone's talking about it, it's already been like 6 months or 8 months from when I was working on it. So it's like, it's kind of funny. Thanks. Yeah, yeah. So there's a section on I talk about the async stuff towards the end of this. Anyway. How does this work SSR wise? If I recall, there aren't holes that fill in the same way, but it's been a long time since I looked in the one thing. Yeah, I've been thinking about this. SSR is tricky because it was one of the last things that I was like debating. Like it was a long time ago, but when I was like vetting this concept, we have to create async similar to resources where we could do the same re-render model like we do right now, where we re-render components. So like, and we cache the create async. What's interesting though is we know whether to fetch again based on whether something through or not. Do you know what I mean? So like, I think we're actually safe, assuming that we didn't fetch if it threw. Like when you're chaining async, that was one of the problems I was trying to solve. To be fair, SSR is the hydration I haven't gone to so far. I've been only working on client side stuff. So yeah, is it create async support async generators? Yes, but I'm not sure how I feel about. Me and Dev have already hit some stuff we talked about on the server signals stream. Like technically, if you just pass an create async, takes a promise or an async generator, but it only suspends during the initial until it gets its first payload, which it's a choice, right? My reason for thinking that is the correct choice is if someone wants to wait till the end to show the data from the async generator, then they could just convert the generator into a promise, essentially. The benefit of supporting generators the way that I'm explaining, where it's like basically until it gets the first chunk of data, it's suspended, is that it just gives you like a pipe, right? It just kind of, yeah, I don't know. Yeah, you think that's the correct choice, yeah. So yeah, I've already implemented that part as well. I'm interested to understand what the hack for SSR looks like, because it's not like we're going to sit there and I don't think we're going to sit there and process the whole stream. I'm guessing it's basically, again, the same logic. When the first chunk or the first piece comes in, we assume suspense is over. That's what gets flushed. And then the rest of the data gets serialized over the wire, and we just write it in on the client. So basically, stream, first piece of data. Okay, stream hits, data hasn't connected to the stream data, suspends, flushes shell. First piece of data comes in, suspense boundary resolves, sends it to the client with that data. Additional data comes in over the stream on the server during the SSR process. It then serializes into the page's HTML, like as part of the streaming. Yeah, I don't know. I honestly don't know how to do this with SSR, because like it's almost like it's almost like if you never close the stream, the page would never stop loading, because you would basically serialize it through that initial thing. Getting the stream to pick up again differently in the client is not something that I know what we would do. I think that's been my biggest concern about async generators as a primitive on the basic side, because it works great on client side only, but I don't know how to make it work with SSR without it being like this weird thing where like the stream just keeps the original HTML request open and it just keeps on streaming it into the page, which is really odd. Anyway, maybe Dev will figure that out for me. Yeah, I don't know. I don't know if there's anything more with this example I wanted to talk about, but I'm glad to get some clarity on the creative effect question. At least it helps me at least understand everyone's perspective a little bit better. Yeah. Okay. Yeah, I think that's what I wanted to get out of this async segment. Yeah, I think that's what I wanted to get out of this. Other than say that I'm very stoked about this demo. It makes me very happy to see in one small place all these concepts and ideas coming together. I think it demos well. Yeah. Yeah, I mean, you could all, yeah, I mean, I think I don't even want to think about what the first stream does with async generators. I feel like that's only holding the flush up to the first chunk again. Basically you treat async generators as only unresolved until the first piece of data comes. So the first stream would work the same way. Until the first piece of data comes, we hold the stream. I haven't added any of the hydration or SSR mechanisms into the wrapped around the core primitives yet. We'll see how that works. I think that's one of like those things that everyone wants a separate signals library, which I built now, and pulling stuff in and figuring what stuff goes. But it's like this extra layer, and it's funny because so much of the mechanisms are all signals anyways. So it's like, do I just like build very solid kind of specific stuff seemingly? Like it's hard with streaming and hydration because they require serialization, but like I don't know. I'm gonna see how that split works. It feels like splitting for the sake of splitting is just like adding an extra like layer of wrappers and overheads to something that could just be straight up optimized. I know everyone wants like a separate signals library, and we do need it so that people can run signals on the server. So like I think this is probably sensible for this. It's an interesting split to me because I'm used to having complete power, like just like build exactly what I want to build, and trying to like look at this as like a general solution that also powers the other one is just like walking through tape. Well, I mean, the problem is certain ideas are core. Like you can't really build transitions on top. They have to be core, like or transactional stuff. The suspense type stuff could be built after with the queues, but it's like you almost have to expose too much to put it in fully in user space. So like there's a lot of like async type adjacent considerations that really require you getting your hands in. Just abandon SSR. Yeah, there we go. Solved. You don't need a separate signals library? I thought you needed signals on the server. You're not the only one, so I mean, I've been hearing this complaint for years. Anyway, let's see if we can whip up a This Week in JavaScript or something. Give me a moment as I put my stuff together. If you haven't liked the YouTube video, please do. we actually have a decent audience on YouTube today. I'm sorry I haven't been paying attention to Twitch, and it shows there's only 20 people on Twitch right now. YouTube's like over 100. Yeah, I did not get any new Twitch subscribers today. I don't push Twitch hard enough. Not that I am in this for... Oh no, I did. Julio Burgos subscribed with Prime way back at the beginning of the screen. Thank you very much. Anyway. Okay, so let me just get some stuff together for this week in JavaScript. I'm sorry the rendering explanation was a bit of a mess. Having the stuff crash on me multiple times was not fun. The funniest thing is, I mean, I got to play with it. You guys are talking about some of the video quality stuff. I've been having issues with my green screen and the lighting and stuff. I'm getting a lot of edge blurring, and I didn't get this on previous versions of OBS, and I tried to play with the settings before stream, and I'm still having issues. So yeah. Let's get into... I wonder if I should put my tier list up from earlier. Let's see. I'm just getting everything ready. All right. When's the last time I streamed? It was a little... Okay, there it is. January 10th. Okay. Duplicate. Let's go to solid. Duplicate. Oh yeah, there's a couple spicy ones from my perspective on this one. Let's go to bookmarks. I forgot what I've been talking about the last few days. All right. That's good enough to get started. I haven't really been on socials, as you guys can imagine, because I've been focused so much on yeah, God, I haven't retweeted practically anything from the solid account in like 2 weeks. I'm the worst. Okay. B-Sky app. Okay. Let's see if there's anything on my profile here. Yeah, so 14 days ago I did a stream, which means I talked about all of this stuff on stream. Yeah, okay, there's nothing on Blue Sky that's specific anyways too. Okay, good. Let's do this. And talk this week in JavaScript. Okay, so switch over to here. This one's probably gonna be short, except for if I can find some spice out of my bookmarks. But let's see what my perspective is on this stuff, because honestly, I've been so deep down the reactivity rabbit hole that I have just not been up on stuff. So yeah. First off, yeah, I mean, what do I got here? It's 2025. Did your company budget money towards open source that runs it? I'm enjoying a lot of this push that David Kramer's been doing towards open source. Obviously, he's been hiring great people like myself, TK Dodo, and he actually has a post where he lists like a whole bunch of people. Nate Moore from the Vastro, like he was talking how he'd want to hire. He had a whole bunch of people. There's a different tweet about that, but obviously he's my boss, so you're like, we're just saying that, but no, I obviously like seeing people put money where their mouth is. Yeah, okay. Yeah, yeah, okay, yeah. TK Dodo, like React query. Anyways, where was I? Yeah. I'm trying to think if there's anything else on this. Yeah, here's the one. I think this is an old observation at this point, but Ken Wheeler talking about the connection between programming and music. And he said something literally 90% of open source you use is written by failed musicians. Which is kind of funny. Okay, I'll grab this one and this one to see what's going on in a minute. Um, yeah, I don't know. I honestly, and after Shruti called me out on like myself law, I feel funny because I did like myself this thing as well. But yeah, I post up music from my old band, Mr. Solid. If people ever want to check that out, self promo. Here we go. Yeah, you caught me right off guard there. Lots of albums over the years. I played with a band for like 15 years. Just like, yeah. Anyways, good stuff. But it was an interesting because I actually got kicked out of university. That is actually an important part of the story. I'm not telling people to get kicked out of university. I was dumb. I literally spent my time doing music. I like would stay up late, and it seems like business hours for doing music was between 10 and 1 a.m. Like that's when you got everything done. And talking to bands, and but I'd be practicing before that, and I didn't go to class. I the final straw was that there was like a class that I thought I dropped, and I literally like just didn't show up for the tests, and it was enough to get my grade under passing. So yeah, I don't know. It's interesting. I did go back and get my degrees, so for what it's worth, but that was for me, not for the knowledge. I'm not suggesting people don't go to university, but it was just interesting observation. All right, who we got here? Talking about propping up bosses. My previous employer, Matt Billman from Netlify, started writing a blog again. Built it with Astro. I thought I'd just share it so people can check it out. He's just talking about the importance of the web, right? And just like why the web is a great place. But I'm hoping this is the start of something great. So just putting out there, Matt isn't always the most pushing on social. Like you don't see him that much. The guy runs Netlify, and yeah, he's crossed 10K followers on Twitter. Like that's not what he's about. But I find what he has to say very insightful. So yeah, more people should check him out. As I said, he's not the kind of person to get in your face. It's I think it speaks perhaps the difference in company, between say like if you were to compare Netlify and Vercel, it's a very different vibe. And I think that goes all the way to the top. So, but you can just yeah. So yeah, very, very cool. But does it score in Lighthouse? It's built with Astro, I'm sure it is. Oh, UBC, there you go. Another UBC grad. Huh. Yeah. Um, but actually, this is kind of related. Because someone's like, now we got to build an install start, right? And actually, probably not. If you're building a blog like that, Astro is the perfect platform to do that, right? Um, yeah, I made a comment because I've been talking a lot with, yeah, I'm just trying to see here. Yeah, I don't need to do that. I've been talking a lot with Tanner and Fred at various points. If you remember way back to Jamstack Conf 2022, we had Theo was making it like we had some secret pact alliance that would shape the future or something. We've been trying to see if we could work closer together for ages. Me and Tanner have managed to get there with Start, but and I want to get Tanner back on stream in the next few weeks to actually talk about that. But essentially, I was talking to them because people started kind of realizing that meta frameworks aren't general. I was talking about this in my article, right? But like they are kind of more specific. It's funny, like the frameworks are pretty general purpose. I mean, they might be good at client rendering, but like you need client interactivity, presumably in lots of things. But the meta frameworks aren't as much. And I wrote this statement which made no sense to anyone. React compiler is to signals, or fine-grained rendering, to be clear, as Next.js is to Astro. And it's like when you have a goal in mind, there's like the direct path that is very very efficient at accomplishing that and catering to its specific goal. And then you have like the indirect path that kind of does it, maybe not quite, and misses maybe the primary audience or goal, but maybe is more generalized perhaps, but also way more complicated. And like we talked a bit about the difference between signals and React compiler in the past. It was just Next.js is targeting the same group as Astro. People wouldn't expect it first because React framework, you want reactivity, but they're actually aligned. Like they're actually sitting at the same place. It's funny because people talk about their blog site. Don't build your blog site with solid start. I mean, you can, but why would you do that, right? And Colin, creator of TRPC, was like build. I'm gonna show you this thread. He was building. He was building this like, showing that he's like, RSC is a shocking pleasant way to make static sites. I'm surprised it's anyone, right? Because they kind of are good at this. This is what the use case is. Like the PHP, you load some data and then you load it in and you're like, ta-da, I'm done. And then he was like, well, actually, the equivalent of Astro is pretty fresh, It's basically the same thing. It must be admitted that the final Astro build is 29 kilobytes versus 841 kilobytes for Next.js. But Next gives link prefetching and image optimization out of the box. I also like TS files. I don't know. Okay, that's fine. To be fair, there is TypeScript support here in Astro. Astro does actually have link prefetching and image optimization. It might not be turned on by default, but it actually has both these features. So I actually, at the end of the day, it's a syntax preference and 29 kilobytes versus 841 kilobytes. That's the important part, right? So the next comment is Astro has all that stuff. Yeah, I'm sure. I'm sure. Yeah, Ben got in here. Yeah. So, like, basically, what I'm getting at here is, I didn't. He posted this the same day after I posted what I posted. It had nothing to do with it. This is kind of what. It's kind of weird when you don't need an 840 kilobyte blog site. Do you know what I mean? Like, I told you not to build your static site with Astro, but should you be building it with Next app directory? The funny thing is, I don't know. Like, this is kind of the question or thought. Oh, we got a raid coming in from I can never pronounce the names. Missio and Misio. So thank you very much for coming in. We're just talking about some recent stuff in socials on JavaScript framework kind of zone of things. Are you surprised you don't refer to it in block DOM? Because it's the only one I know of. I mean, in Rust that's true, but there's like the block DOM framework itself. There's million. In a sense, DOM C was a block DOM too. There's been libraries over time, but popular ones, I guess million is probably the most popular. Eevee might have done something in Eevee 3 or 4 that's block DOM that could explain that. Yeah, imagine not, but I appreciate the raid. Yeah, EV is, yeah, okay. It's it's interesting. Yeah, interesting to see if it makes its way into more mainstream. That what instead happened is the frameworks went more to fine grained renderings, signals, kind of stuff. Yeah, I mean it's possible. Aiden's been focusing other places rather than the tool itself. He's been trying, million lint or all the other stuff. So he might not be putting as much stuff in there. It's still around as far as I know. Anyway, where was I going here? Oh yeah. Yeah, what is Next.js for? And this is actually kind of tied into one of the bookmarks I was looking at here because a couple of these showed up that say, honest opinion, Next is not the best option for interactive heavy apps like cal.com, especially with the app router with RSCs. Next.js for Vercel is the WordPress for web developers. It's the easiest way to launch SEO and performance-focused websites. However, to build highly interactive or data-intensive apps, Next.js falls short in comparison with other frameworks. Probably the most interactive dynamic app I've ever built. Seen is V0 Dev Full Stack Next, featuring very fast loading times, sharing public, private, and listen, and dynamic navigation. It depends on what you consider dynamic from an interaction standpoint. It's interesting where this kind of tension is coming in. Part of the problem is there's a mutation stories like dashboard, like not even dashboards, but like mutation stories where your primary content changes often doesn't RCs don't help you there because they have to go back to the server and pull everything. You don't get granular updates. You can't be optimal there, like especially in terms of mutation. So it's like it's not the best pattern for a lot of highly interactive applications. WordPress sites are blazingly can be blazingly fast, especially on the static side. Yeah, okay. So performance are more led because of the app directory. Yeah. It's just it's interesting to me that it seems obvious to me that RCs as an architecture would not be as good for where the content changes, like the primary content changes because like wrap a lot because they do everything wholesale. They rely on caches on the server in scenarios where you could actually just not make the request in the first place, right? And the reason that this is kind of relevant here is because like I keep on circling this. It's an interesting tension. From their perspective, with aggressive preloading and server caching apps, they are a good choice for interactive apps. Yeah, it depends on how interactive. I don't actually think they go all the way right. Technically, you can stick classic isomorphic, interactive type stuff in your next app, but you have to close the loop on the mutations, right? If you're using server actions to re-render part of the page, it's really hard to like do granular updates on top of that. You end up trying to introduce it's very hard to like bridge that gap. Um, you people end up just making the use client larger and larger. The joke is like you just put use client at the top and you just forget about that, right? I'm not saying that's right, but I'm just saying like that's where the tension is here. Um, so it's like I, it's interesting because I feel like where it's controversy. I've been kind of critical a bit of server islands because even though they load from the CDN really quick, they can't parallelize the process of fetching the data for the server island, so to speak. So they're actually slower to load the secondary content that comes in the dynamic part than if you had streamed from the edge or done PPR. So ultimately, you see the static content faster, but the parts that load in are slower. So if your primary content is not static, then server islands are the wrong solution for you. But if your primary content is, generally not getting invalidated all the time, then it's way simpler and way more performant. I called it the new Jamstack than doing what Next is doing. So it's like it's this very interesting in the middle zone where it's not the best at heavily interactive stuff and it's not the best at less interactive stuff. And the arguably you could say being in the middle means the more you expand, the more range you have, but arguably the better the solutions are on the outside, the less space it has to exist if the two ends meet. Yes, right, of course. But that only matters like if your primary content can't be served from the CDN, then like like my Hacker News example, silly thing. I mean, you'd probably catch some stuff there, but like if your primary content can't is literally like a header bar, then like server islands are going to be worse. Yeah, I mean, local first is like the extreme on the others, like not RSC side of things. It's the extreme of the client granular thing that I'm talking about. So it's just it's an interesting thing because RSCs were designed to make Next fill into that zone, but had they gone so far that they actually have departed? We did a whole stream last time about this, but it's interesting to actually see the conversations pop up now on Twitter about this, right? Like, I don't know. It should be interesting to see how this kind of progresses out. Before I get off this platform and look at that blue sky thing that I have to look at, Corvu's calendar component is live. Aim to be a simple, lightweight calendar component for solid.js ecosystem. Thank you, Jasmine. Super, super stoked about this. Every time, like we have, it's. I told you it's endless, right? People are like, oh, where's your blank library? And you're like, oh, we have ShatCN. We have all the popular component libraries and approaches and things equivalent to this and that. And then people are like, okay, but where's this one component? And you're like, oh, like a date picker or a calendar or something. It's like they are the harder ones, and sometimes you will have all the components except for that one in a thing. So I'm very stoked to see, the calendar component. It's one of those ones that I know takes a lot more time to make good, and I'm glad to see that done. The data loading side of RCs are overhyped, while the automatic code splitting is barely mentioned. Yeah, yeah, it's the code size part is the part. It's funny though, but like it's interesting because yeah, in theory it should be this. Do you know why? It's because in theory it should be the same gains, almost equivalent to islands. But the problem is that because the baseline got bigger, people who make a lot of noise and make their like simple demo apps actually stuff got larger with Next. So like from that perspective, like in real apps, I think there's definite positive benefit on the code size because of this. Um, but the problem is anyone doing anything trivial just to kind of be like, look at this, saw things got worse, and no one's like the most complicated app someone's going to build as a demo app is a blog site, which means that someone could build it 10, 15, 20 times over with Astro plus Svelte or Solid before they even catch up to the next app that says hello world. So like it, that's why people don't talk about it. But if you talk about a really large app that has lots of code and component things, there's a huge benefit, right? Sending, are you sending 1 megabyte of JavaScript instead of 10 megabytes? Yes, right. And then the problem is people doing simple stuff go, okay, I'm sending 1 megabyte when if I choose this other solution, I'm sending 100 kilobytes. Yeah, I imagine so. Yeah, I mean, RCs are basically islands. It's the same. It's yeah, like Islands is the only difference is the client-side routing capability of RSCs, and keeping shared preserved state. Island with like view transition and stuff doesn't handle preserved state and hydration properly. But like from the initial render standpoint, like MPAs are the same mechanism on Islands, so going all the way back to like Marco in 2014. Yeah. RSCs aren't special in that. They are actually just an implementation of Islands from a certain perspective. Yeah, and state preservation. Because just adding client-side routing to Islands doesn't make it equivalent to RSCs. You have to be able to handle state preservation. Okay, so what's this blue sky thing I have to look at? Because I think I'm at the end of, yeah, I'm good here. I mean, the only last thing here is new honeypot documentary coming out, the Angular documentary. I'm, again, shameless plug because I'm part of it. I actually recently did the Vite one too. I've been in 3 honeypot documentaries now. I think that's the record according to them, but we'll see. I enjoy them. I like this kind of history of things. I don't know if you guys put speed running, but I'm a huge fan of summoning salt. Um, so like having someone go in our field and keep a history is really cool. Okay, so I'm getting shares. Let's start with this then. Is this the one I want? Yeah, thank you. Yeah, perfect. All right. Just saw an article pointing out the same Preact is broken issue I've been highlighting, and nothing is noted as actually worse. CRA docs make no mention that it's outdated. Pretty frustrating to watch. It if I had a repo and permissions for real time, I'd put sounds like the Reactivity manifold kept permissions and there's a launcher and nothing means. So it is something giving team point. This needs to be championed from the team. Yeah. Oh, this is like a general launcher that launches things. Yeah, we talked about this back when Theo made the beat argument. Here's ever, but since the release of 19, it now breaks installs because RTL. So, oh, interesting. So, like, just no one's doing it. Yeah, going to. Is abandoned. There's yeah, blah blah blah. Okay. So what's I need to find where the drama actually gets in. Okay, we got Spatak. Vite core maintainer. Let's see what this thread looks like. Let's follow it down. Okay, so here we go. Okay. I mean, everything sounds good except the changing installation docs is unrelated. 80% 20. I agreed it shouldn't block, but I feel very certain the safe spots are valid. Use Vite for that. Highly related to CGB and board docs. Okay. Spot is fine compile target output mode. If there's a good reactor that can output spot, we should list that. Vite is not a framework, and we don't recommend cobbling your own bespoke framework from a build tool. Oh, this again. Oh, man, I almost want to. I don't have time to do this. I wrote something on the other day on HackMD. My falling out with React. I could publish this as an article, and it's like right on this. Reactor grade, yes, I think it should be added. Actually, I'm not. Remix move to Reactor is done. Create beat actor to the meta launcher. Select React. Blah blah blah. Whenever it creates feed, isn't it? I mean, talk to the docker or anything else. Okay, so they're talking. Okay, that's great. Blah blah blah. Production app. The correct issue not. Suppose some. Okay, I'm still trying to create React defaults to meta frameworks. Oh, interesting. That's interesting. Because now Beat's talking about changing what they point to with their CLI. Huh. CLIs and CLIs and CLIs. Just kind of funny side because we were actually looking at like our CLI has the same choice where you choose between just static Beat templates and solid start templates. All right, we got a drama one. Doesn't see what Ricky has to say. The launch idea theory has legs, but not if it remains the idea no movement. It's for years and that to consider the move or hoping broken might nail it. Not it. Oh, it's this. Rewrite list spawn recommend beat. No to 6. Yeah, this is such a funny thing. Yeah. I mean, if beat takes it on, I guess. It's just funny. Like, this is such a weird thing, and it's I actually said that in the article that I wrote that this was the like this change in React was the moment that things changed for me with React. I don't know. I don't know if it's premature to show the thing that I wrote. Probably. It's just I was watching Theo's stream on Wednesday, and he was doing a new video on the last framework. And he made a comment about how he could notice that I became increasingly frustrated with React. And he thought it was because they were closing the gap. You know, like basically React was 70% of where I thought it would be. Now that it's 90%, you know, it's close enough that it's good enough. And, you know, it didn't really matter. So that's why I'm frustrated. And I mean, he's partially correct. What annoys me about you know, they did make improvements and stuff, but what annoys me about that last gap is almost like an acknowledgement that they're they're done. And I think that's the problem. I don't think we should ever assume that we're done, right? I think it's dangerous to assume that you're done. Things are changes like the one constant. So like I don't know. I will respond whenever Theo releases his video on the last AI, the last React, the last framework or whatever. I will probably look at that on stream and we'll respond to it. But until then, I don't think I want to poke the bear here. This conversation, other than them still going with like they don't want to promote, you know, bundlers, but they'll let CRA just like burn into the ground is more of a frustration for React folks and not particularly dramatic. It's like we've known they've had this stance for a while. It's like one of those it's really odd stance from the outside. So which makes it hard to understand because you look at it and you're like, just being like do a spa with Vite is such a no-brainer. But their vision for React, which is part of the conflict here, doesn't really allow for that because for them React is not what it used to be. It's not a library. You know, it's just I mean, it's no secret. On my last stream, I was fairly critical of React, and I've just kind of had enough. And so I actually stopped and wrote it down because I was like, when did this really start for me? When, like, because I every 2 years or so I write a reflection on where React's at. You know, I did like 2 years after hooks, and then I did nothing. Like generally, I like keeping a pulse on it because there's like a feeling in the ecosystem around React and stuff. And I haven't written anything in 2 years. Yeah, after the hooks one I did, like finally understanding server components, that was the one I did around 21 or 22. And I think I'm not alone in my sentiment, but I also feel that the language that I chose to use, which is why I don't want to put it in here, is too harsh. This is why they can't recommend React and Beat. Okay, let me see that one. I mean, it's here's a good overview. Suspense with nothing talking what that means. Is React teaming collaborating with folks outside of Brazil at this point? It's like the lack of docs around .use is intentional. The docs are focused on end user, and React doesn't want end users to use .use directly without server components to fetch data. They recommend people use frameworks for data fetching. Use a document in the sense you can cache prominence, blah, blah, blah. So what does this have to do with Beat? Do you mean like from the fact that they don't want they expose external APIs, but they don't want everyone to use those APIs? So this way they don't have to document the things that are like not as refined. I mean, I do this too. It'd be like me documenting what Solid.js web exports a little bit because I don't want you to ever use it. The difference is framework authors don't actually have to use it. So I don't actually, except for the local storage thing, arguably. But yeah, I don't know. It's an interesting place to be. Because if you do React plus Vite, you literally can't do data fetching. Yeah. How does Tenor do data fetching? I mean, yeah. I don't think that's why though. I think we're just seeing like two important philosophies line up in the most terrible way. Like, I don't think it's specifically Next.js. They don't care if it was Next.js or Remix or whatever. It's just like they're trying to change what React is. And then at the same time, there's people who are willing to jump in and like take that torch all the way to for their benefit in terms of like being the one React solution. So it's like, you know, oh man, this is like what I wrote is so relevant to this, but I think I need to save it for my next stream. It's already late enough. It's just yeah, we're gonna leave that where it lies for now. It's so tempting because it's completely on point with this, and I think that like I think we're in a pretty interesting place in terms of like where React sits, and I don't think there's an easy solution for React. I mean, the problem is after a while you build up so much infrastructure, so many pieces that you can't move without breaking. And React is getting to that point where like they tried to take some steps and their feet broke off, like, and then the tick thing and a bit of the shin broke off, and then they're like, okay, we're not moving anymore. And it's fine. It's a natural life cycle, but it also means that React is peaked. That's the term, which is perfectly fine. It just means that like, because like when you're at your peak, you're at your highest potential and you get the most things, you know what I mean? Like, so like React will continue to grow, but yeah, I think that is kind of like where we are now. It means that people mentally should be prepared that down the line there are different things, but people don't want to. But I think we all feel it. Like sometimes you just can't change the boundaries anymore. You can't. You just gotta, you know, React has done exactly what React was supposed to do. I think the crazy part is the people who think that like you like stagnating or like going out this way, like it is a thing that is. It isn't like a good thing or a bad thing, but people who stand behind it as being like a good thing are just kind of like trying to stoke or hide a fire. It's just where things are in its life cycle. React's going to grow like jQuery now. Yes. It's interesting because, well, because they're still working on really important stuff. Getting the compiler and getting RSCs in was like the thing they needed to just kind of like it's like when the guy in the quicksand's moving forward as he's sinking and he just gets puts it in. They may have done it, people here's the thing, yes, people who use things most, love most, they're gonna be naysayers and stuff, so they're going to always say that they're going to be the first people to be negative. It's I don't They might be earning early warning signs. I think it has happened now. You can never tell until you get past it and you can look back. And no fault of Andrew Clark or whatever specifically, but the moment that it became obvious to me was when, and this is not a stab at Vercel again, is when Next 13 was the real React 18 release. That was when they jumped the shark. That's a Happy Days reference, but that was when you're watching the show and you're like, it's so sweet, and then you're like, did they did that? I mean, the show's still sweet, but you like it sticks with you, and then you're like, you think about it later, and then you go back and you go, oh, that was when it happened. It's not like the show deteriorated and wasn't good anymore. It just there was a subtle change, and it took a while to be realized. It's like, fall of the Roman Empire or whatever. So yeah, I mean, I mean, there's it's just where you are. Being at the top isn't a bad thing, right? It just you I think that's the scenario. And for different people who live on different parts of the curve, that means different things, right? There's always going to be people at the very front of the curve who are always chasing the newest things. There's other people who live for the innovation. They live for the change. They aren't necessarily chasing new things just because they care about new things. They like seeing the impact of those changes. But those people you lose once you get near the peak, right? And then like, you know what I mean? Like, yeah, I think React has finally got to the point where I've lost interest. Anyway. Oh, with ending with that somber note, I guess. I don't know. Sorry, that's all I got. I wish I had something. I should save the Angular documentary to now. Like the I was reading this comment from Dev and I was trying to figure out what he meant because I was like, Vue doesn't have fine grained rendering yet, but I guess it will. Angular, I mean, if Vue, if Vue can bring something to the masses, Vue already brought signals, so will bring. But yeah, I guess the idea is that like something that's already established will take the stab enough to to bridge the gap, and then the next thing. Yeah, I don't know. It's interesting. It's just gonna be real. Yeah. Anyway, yeah, I'm sorry about that. I didn't realize I didn't mean to suddenly get so dark. I don't know. Anyway, I think I'm gonna call it a night, call it a week. Hopefully, I can get Tanner in on this stuff soon. As I said, sorry again about the demo not quite going there. I hope you learned something still. Um, you all have a great weekend. I'll catch you later.